How about global thermonuclear war?
Hey there, Hacker Frogs. It's me, the Shy Hat, and we're doing HackerFrogs AfterSchool today. We're doing HackerFrogs free hacking. We're hacking all the things. So let's talk about what we're going to be covering in today's live stream. Let's talk about it. So typically each one of our live streams has a schedule that we like to stick to, and those are typically posted to our Reddit and our Discord. So our Reddit is over here if you're interested, and our Discord is over here. So today is Wednesday, May 13th, 2026, and let's talk about what we're going to be covering today. So the first topic we're going to be covering today is our research topic. So I'm learning about AI because AI is all the rage these days, and we're covering a course called Elements of AI. And if you're interested in taking a look yourself, I'm pretty sure everybody can take a look over here. You don't need to be logged in unless you want to do the exercises. And that's going to be the first hour of today's stream. In the second hour, we're going to be doing some demos for PicoCTF 2026. PicoCTF is a very popular CTF game for learning about cybersecurity skills. And I'm going to be re-recording some of the general demos. I did this, I think it was last week. I did these demos, but I'm gonna have to re-record them because I forgot to not include the background music, and that means I couldn't use that footage. So that's what we're going to be doing in the second hour of today's stream. In the third hour of today's stream, we're going to be doing HackerFrogs AfterSchool, which is a course that I developed that teaches about different cybersecurity skills. We're currently working on the digital forensics course, and we're going to be doing session 3. Session 3 is going to be about Wireshark and packet captures, network packet captures. So look forward to that in the third hour. In the fourth hour, we're going to be doing the TryHackMe copy fail room. Copy fail is a very recent Linux bug that was discovered maybe 2 weeks ago now. And I'm a bit late to the party, but we're here to talk about the copy fail vulnerability, and we're going to be covering that over at TryHackMe and in the fourth hour. We're going to have a bonus topic as well after the fourth hour because I suddenly have a little bit more time. So without further ado, let's put an hour on the clock, and then we can get started with our first topic. All right, so that's 60 minutes, and let me go ahead and put on some... Well, we can keep the Shovel Knight OST here going for as long as it goes. I'll turn down the volume, of course, because I don't want the music to be drowning out what we're talking about. Okay, so let's put that on shuffle and let's begin. All right, so this is Elements of AI, and we're talking about regression in this chapter. So what is regression? I guess we'll do a little recap as well. If you're interested in looking at the same stuff we're looking at, you can find it over at this page that I just left in the chat. Okay, so let's see. So our main learning objective in this section is another nice example of supervised learning methods, and almost as simple as the nearest neighbor classifier 2, linear regression. We'll introduce its close cousin, logistic regression as well. All right? And Marcelo, hello, nice to see you here. What is up? Just finished. Alright. I'm not too sure what he just finished, but anyways, if you have any questions, Marcelo, Marcello or Marcello? Cello, right? Marcello? Anyways, if you have any questions, please let us know. Okay, the difference between classification and regression. There's a small but important difference in the kind of predictions that we should produce in different scenarios. While, for example, the nearest neighbor classifier chooses a class label for any item out of a given set of alternatives, like spam ham or the digits 0 to 9, linear regression produces a numerical prediction that is not constrained to be an integer, a whole number as opposed to something like 3.14, so linear regression is better suited in situations where the output variable can be any number, like the price of a product, the distance to an obstacle, the box office revenue of the next Star Wars movie, and so on. So the basic idea of linear regression is to add up the effects of each of the features variables to produce the predicted value. The technical term for adding up, for the adding up process is linear combination. The idea is very straightforward and it can be illustrated by your shopping bill. Okay, so I think we'll skip down to the exercise where we talked about how we can illustrate an example of linear regression. Suppose an extensive study is carried out and has found that in a particular country, the life expectancy, the average number of years that people live among non-smoking women who don't eat any vegetables is 80 years. Suppose further that on average, men live 5 years less. Also, take the numbers mentioned above. Every cigarette per day reduces the life expectancy by half a year, and a handful of veggies per day increases it by 1 per year. Okay, let's make this a little bit bigger. Calculate the life expectancies for the following example cases. For example, the first case is a male, subtract 5 years, smokes 8 cigarettes per day, subtract 8 times 0.5 or 4 years, and eats 2 handfuls of veggies per day. Add 2 times 1 equals 2 years. So the predicted life expectancy is 80 minus 5 minus 4 plus 2, that is 73 years. Okay, so we've got a list of different subjects, so male, male, female, female, the number of cigarettes they smoke per day, vegetables that they eat per day, and their life expectancy that we need to calculate. So your task is to enter the correct value as an integer, a whole number, for the missing sections A, B, and C above. So we calculated these. I think I'll do 1 as an example. Yazanchi says, nice linear regression. This reminds me of my linear algebra final exam. Thanks, HackerFrog. You already helped me for that. Yazanchi, hello. Nice to see you here. We're just trying to understand how machine learning works and how AI works, I guess, in relation to it. We're just we're trying to work through this course because this is something that I should know about, and I might as well use this as a warm-up. But hello. Nice to see you here. Okay, so we're going to suppose that we've got a male who eats 6 hands of vegetables per day and smokes 0 cigarettes per day. This is probably the most healthy male in this study over here. All right, let's go ahead and model it out. Does Elements of AI do OSAI certs? I don't think so. I didn't even know that OffSec offered an AI course. Let's see, OffSec OSAI. Okay, OffSec Learn 1. Learn 1? AI Cybersecurity Course and Certification. Oh, they do offer... So the OffSec AI Red Teamer, OSAI and OSAI Plus, hands-on AI security certification validating real-world offensive skills. It costs a lot of money. But of course, every big company, every big security company is offering AI security courses these days. But yeah, if anybody wants to take a look at this course, I've got the link over here. But otherwise, we'll go back to our other course. Okay, so we're trying to figure this out. They say that so the baseline life expectancy is 75 years for males. So that starts off at a baseline of 75. And we also have to take into consideration the cigarettes that they smoke every day, which is 0. That's a very easy calculation. And the vegetables that they eat every day. So 6 adds 6 years to the figure. So that is going to total out to 81 years life expectancy for this particular subject. Nizansi says, yes, it's new and there's very much hype. Do Elements of AI, is it enough to learn AI programming? I'd say that this is supposed to be an introductory course to AI. They've got another course called Building AI. I'm not too sure how this one differs because I haven't looked at it. But if you're interested, here's the link. We're just starting off with the basics right now because I don't want to overcomplicate. Well, I don't want to jump into a subject where I don't have the baseline knowledge. That sounds like a very bad idea. So anyways, we calculated how many years these subjects are supposed to live, depending on, you know, these variables here. And we're going to move to the next one. So in the above exercise, life expectancy of non-smoking, veggie-hating women, what? 80 years was the starting point for the calculation. The technical term for the starting point is the intercept. Intercept? Huh. Technical term for the starting point. So the starting point for linear regression is known as the intercept. Okay, we'll keep this in mind. Okay, project. Hello, nice to see you here. What are we doing today? So if you're interested in what we're doing today, we've got our schedule over here on the Reddit. You can take a look. We're going to be starting off with our AI introduction course. So there's a bunch of different terminology we need to understand about AI before we can start learning about it. So let's see. So the technical term for starting point is the intercept. We'll return to this below when we discuss how to learn linear regression models from the data. Okay, learning linear regression. So above we discussed how predictions are obtained from linear regression when both the weights and the input features are known. So we are given the inputs and the weight, and we can produce the predicted output. When we are given the outputs, the inputs and the outputs for a number of items, we can find the weights such that the predicted output matches the actual output as well as possible. This is the task solved by machine learning. Okay, so we've got our example. What is this? Continuing the shopping analogy, suppose we are given the contents of a number of shopping baskets and the total bill for each of them, and we were asked to figure out the price of each of the products, potatoes and carrots and so on. For one basket, say 1 kilogram of sirloin steak, 2 kilograms of carrots, and a bottle of Chianti. Even if we knew that the total bill was 35 euros, we couldn't determine the prices because there are many sets of prices that will yield the same total bill. With many baskets, however, we will be able to solve the problem. Okay, but the problem is made harder by the fact that in the real world, the actual output isn't always fully determined by the input. So what is our example problem here? Okay, so one basket has these items here. And we know that the total bill is 35 euros. Determine the prices of the following items. Okay, so 1 kilogram of sirloin steak, 2 kilograms of carrots, and a bottle of Chianti. So we know the total of the 3 items were 35 euro. Okay, and let's continue. So in the real world, the actual output isn't fully determined by the input because of various factors that introduce uncertainty or noise into the process. You can think of shopping at a bazaar, where the prices for any given product may vary from time to time, or a restaurant where the final damage includes a variable amount of tip. In such situations, we can estimate the prices, but only with some limited accuracy. Finding the weights that optimize the match between the predicted and the actual outputs in the training data is a classical statistical problem dating back to the 1800s, and it can be easily solved even for massive datasets. We will not go into detail of the actual weight finding algorithms, such as the classical least squares technique, simple as they are. However, you can get a feel of finding trends in data in the following exercises. So we're visualizing linear regression. A good way to get a feel for what linear regression can tell us is to draw a chart containing our data and our regression results. And as a simple toy example, our dataset has one variable, the number of cups of coffee an employee drinks per day, and the number of lines of code written per day by that employee as the output. This is not a real dataset, as obviously there are other factors having an effect on the productivity of an employee other than coffee that interact in complex ways. The increase in productivity by increasing the amount of coffee will also hold only to a certain point, after which the jitters distract too much. Okay, so we've got lines of code written over here from close to 0 to 60 lines of code. 60 lines of code a day. I'm not too sure whether or not that's a lot of lines of code or not a lot of lines per code. And we got cups of coffee per day. So it seems like like there's a direct correlation between the number of cups of coffee. So you've got 10 cups of coffee per day, and they're writing a lot of code. Anyways, when we present our data in the chart above as points where one point represents one employee, we can see that there is obviously a trend that drinking more coffee tends to be associated with more lines of code being written. Recall that this is completely made up data. From this data set, we can learn that the coefficient, or the weight, related to coffee consumption, and by eye we can already say that there seems to be somewhere close to 5. Since for each cup of coffee consumed, the number of lines programmed seems to go up roughly by 5. For example, employees who drink around 2 cups of coffee per day seem to produce around 20 lines of code per day, and similarly at 4 cups of coffee, the amount of lines produced is around 30. Okay? It can also be noted that employees who do not drink coffee at all also produce code, and it is shown by the graph to be about 10 lines. This number is the intercept term that we mentioned earlier. The intercept is just another parameter in the model, just like the weights are, and can be learned from the data. Just as in the life expectancy example, it can be thought of as the starting point of our calculations before we have added in the effect of the input variable or variables if we have more than one, be it cups of coffee in this example or cigarettes and vegetables in the previous one. The line in the chart represents our predicted outcome, where we have estimated the intercept and the coefficient by using an actual linear regression technique called least squares. This line can be used to predict the number of lines produced when the input is the number of cups of coffee. Note that we can obtain a prediction even if we allow only partial cups, like half a cup, 1/4 of a cup, and so on. Okay, so we've got another exercise we're going to be working through, and this is life expectancy and education. Life expectancy and education, part 1 of 2. Okay, so what are we doing here? Let's study the link between the number of years spent in school, including everything between preschool and university, and life expectancy. Here is data from 3 different countries displayed in a figure represented by dots. Okay, so years of education is over on this axis, so 0 to 22, and there's life expectancy in years. So we see that it seems that there is some sort of relationship between the number of years you spend in school and the life expectancy over here. Okay, so there are 3 dots which are representative of 3 countries. Okay, we have one country where the average number of years in school is 10 and the life expectancy is 57 years. So 10 years in school and 57. So this is the first data point over here. And another country where the average number of years in school is 13 and the life expectancy is 53 years. Okay, so that's 13 and 53, so... I don't know if there's anything that we have to concretely draw from this example here. Okay, and a third country where the average number of years in school is 20 and the life expectancy is 80 years. So this is this would be pushing towards more years in school, meaning longer life expectancy. You can drag the endpoints of the line, of the solid line, to position the line in such a way that it follows the trend of the data points. Note that you will not be able to get the line fit perfectly with the data points, and this is fine. Some of the data points will lie above the line and some will lie below it. The most important part is that the line describes the overall trend. After you've positioned the line, you can use it to predict the life expectancy. Given the data, what can you tell about life expectancy of people who have 15 years of education? Important. Notice that even if you can obtain a specific prediction down to a fraction of a year by adjusting the line, you may not necessarily be able to give a confident prediction. Take the limited amount of data into account when giving your answer. Okay, so select the correct answer. So this is multiple choice. Let's take a look at the graph, and we also need to take a look at what the question is asking us. So let's see, life expectancy of people who have 15 years of education. So let's just copy this. We'll go back to our text editor, okay? And so let's see, this is exercise 17, I think. Let me double check that. This is exercise 17, life expectancy and education. Okay, so what we're trying to do is we're trying to figure out the life expectancy of people who have 15 years of education. So we have 3 examples. So the 3 examples are, was it 10 years? "10 years education and life expectancy of," what was it? 57. Okay, the second example. The second example is more, right? 13 years in school and 53 years of life expectancy. Oops. Life expectancy of 53. And the third example was 20 years. 20 years, life expectancy of 80 years. Okay, so we've got our 3 examples over here. So 10 years of education, 13 years of education, and 20 years of education. So what we need to do is we need to figure out the life expectancy of people who have 15 years of education. So 15 years of education means that it's going to lie somewhere between these 2 figures. So 53 and 80. So our question is 15 years education and life expectancy we don't know. So we need to figure this out. So if we go halfway between 53 and 80, that might be the answer. Of course, if anybody in chat has a better way of figuring it out, let us know. And if you've also done like some sort of course that is related to this, let me know as well. You might be able to help out. Okay, so 13. So how many years separate this? So that's 13 and 20, so that's like 7 years. So 53 and 80. You can move the dots on the chart to position the line to get an approximate. Star6, hello, nice to see you here. Okay, so if we put one line here and the other line life expectancy in years. So I'm looking for somewhere in the neighborhood of this. So, I mean, I'm not too sure if any of the data points are solid. Okay, so we're looking at 15 years of education. 15 years of education here, and if we go up, then we see somewhere in the neighborhood of 60 to 70 years. So I wonder if that's one of the answers. Between 60 and 70, we go down. It is certainly between 60 and 70 years. It is certainly 70 years or less. It is probably less than 90. It is exactly 64 years. I mean, I'm gonna guess it's between 60 and 70 years. And we'll submit this. Okay. The answer is not correct. It is probably less than 90. So I guess with these, with this data set, we only know that it's going to be less than 90. So I guess the data we have here is not enough for a concrete prediction. Okay. Okay, incorrect. The few data points that we have make it impossible to say anything about the life expectancy only based on the data. Of course, one can know a great deal about life expectancy from other sources, but the data in the above chart is insufficient to do so. The first choice is clearly stating too much. So the first choice is too much, right? While the intervals in the second and third choice are likely to be valid, the word certainly makes them unjustified. Certainly. So I guess it's exactly and certainly are these boogeyman words that we need to avoid when we're dealing with limited data. I think this is what we're supposed to understand. Okay, so while the intervals in the second and third choice are likely to be valid, the word certainly makes them unjustified. There is a chance greater than 0 that the value turns out to be, for example, greater than 70, thus the only choice that we can be comfortable with is the fourth one, probably less than 90. Probably less than 90, so it's not even certain about less than 90. Okay, we'll continue. Okay, exercise 18, life expectancy and education, part 2 of 2. In the previous exercise, we only had data from 3 countries. The full data set consists of data from 13 different countries presented here in a graph. Okay, so we still have, I guess it looks like we've added to the number of data points in this case. Can't exactly correlate the data with limited info. Yeah, this is something we need to understand, I guess, while we work through this course. So we've got a chart over here, and what we need, I mean, I'm guessing that what we need to do is we need to find something around the middle to estimate the life expectancy. So somewhere around here. But let's keep on reading. Based on this data, would your prediction about the life expectancy of people with 15 years of education change? If so, why? Which of the following options would best match your estimate of the life expectancy for people with 15 years of education? Choose the most specific option that you think is justified by fitting the straight line model into the above data. Saint of Ice, hello, nice to see you here. Stasix, yes, I think we're supposed to understand that, yeah. And have fun lurking, Saint of Ice, no worries. Okay, so select the correct answer. So 15 years of education, how long will they live? So we've got our new answer here, and we've done a best fit to the data points over here. So we got a couple of examples that are above and below, so I'm guessing that this is a pretty standard deviation. And we've got 15 years of education. That puts us at around 65. Around 65, between 70 and 60. And I wonder if that's one of the answers down below. Okay, probably between 69 and 71 years, probably between 50 and 90 years, probably between 45 and 50 years, probably between 15 and 150 years. You're looking at 13 years. 13 years. Oh, was I? Okay. Let's do a recalculation. So between 14 and 16 is 15 years of education. We'll go up, and it looks like that sits on 70. So if it sits on 70, or like 69 or something like that, I'm not willing to say exactly 70, but let's see what the options are. Probably between 69 years and 71 years. So what we saw was around 70. Between 69 and 71 years. I mean, this has to be a this has to be a trap, right? We've got the full data set though. So let's try this, and if they tell us that we're wrong, I guess we'll find out. Okay, the answer is not correct. So they still wanted like a larger margin. So between 50 and 90 years. 50 and 90. So let's see. So we've got our... So between 50 and 90. So they wanted a larger margin. Alright. Alright. So the first choice would be clearly an odd estimate. No, right? The second choice is correct because it fits the general trend. So the general trend is between 50 and 90. And all data points with more than 12 years of education fall within the interval. The interval 69 to 71 years in third choice could well include the actual data, but based on the above data, it would be too bold a claim to note the outcome with such a high amount of accuracy. The interval 15 to 150 years in the fourth data would almost certainly include the actual value, but we think that it would be a poor summary of what we can learn from the data from the reason that is too vague. Okay, Snosik says, I think you need a larger room of error due to the deviance on the line. I mean, I guess this is what they're trying to teach us because the data doesn't line up perfectly for any of, well, it only lines up perfectly for maybe one or two, and the rest of them have some amount of deviation. So we want something that is not too broad as to encompass everything, and not too specific to be inaccurate. So I guess what they were looking for was between 70 and 50, which does sit between the standard, the amount of deviation we see in these data points. Okay, we'll move on. Okay, it should be pointed out that studies like those used in the above exercises cannot identify causal relationships. In other words, from this data alone, it is impossible to say whether studying actually increases life expectancy through a better informed and healthier lifestyle, or other mechanisms, or whether the apparent association between life expectancy and education is due to underlying factors that affect both. It is likely that, for example, in countries where people tend to be highly educated, nutrition, healthcare, and safety are also better, which increases life expectancy. With this kind of simple analysis, we can only identify associations which can nevertheless be useful for prediction. Okay, so we're learning about machine learning applications of linear regression. Linear regression is truly the workhorse of many AI and data science applications. It has its limits, but they are often compensated by its simplicity, interpretability, and efficiency. Linear regression has been successfully used in the following problems to give a few examples. Okay, prediction of click rates in online advertising, prediction of retail demand for products, prediction of box office revenue of Hollywood movies, prediction of software cost, prediction of insurance cost, prediction of crime rates, and prediction of real estate prices. So could we use regression to predict labels? So as we discussed above, linear regression and the nearest neighbor method produce different kinds of predictions. Linear regression outputs numerical outputs, while the nearest neighbor method produces labels from a fixed set of alternatives, that is, classes. Where linear regression excels compared to nearest neighbors is interpretability. What do we mean by this? You could say that in a way, the nearest neighbor method and any single prediction that it produces are easy to interpret. It's just the nearest training data element. This is true, but when it comes to the interpretability of the learned model, there is a clear difference. Interpreting the trained model in nearest neighbors in a similar fashion as the weights in linear regression is impossible. The learned model is basically the whole data, and it is usually way too big and complex to provide us with much insight. So what if we'd like to have a method that produces the same kind of outputs as the nearest neighbor, labels, but is interpretable like linear regression? Okay, so we've got a new concept here. It's called logistic regression. Logistic regression to the rescue. Well, there's good news for you. We can turn the linear regression method's outputs into predictions about labels. The technique for doing this is called logistic regression. We will not go into the technicalities. Suffice to say that this is the simplest case. We take the output from linear regression, which is a number, and predict one label A if the output is greater than 0, and another label B if the output is less than or equal to 0. Actually, instead of just predicting one class over another, logistic regression can also give us a measure of uncertainty of the prediction. So if we are predicting whether a customer will buy a new smartphone this year, we can get a prediction that customer A will buy a phone with a probability 90%. But for another, less predictable customer, we can get a prediction that they will not buy a phone with 55% probability. Or in other words, they will buy one with 45% probability. It is also possible to use the same trick to obtain predictions over more than 2 possible labels. So instead of always predicting either yes or no, buy a new phone or not, fake news or real news, and so forth, we can use logistic regression to identify, for example, handwritten digits, in which case there are 10 possible labels. An example of logistic regression. Let's suppose that we collect data of students taking an introductory course in cookery. In addition to the basic information such as the student ID, name, and so on, we also ask the students to report how many hours they studied for the exam, however you study for a cookery exam, probably cooking, and hope that they are more or less honest in their reports. After their exam, we will know whether each student passed the course or not. Some data points are presented below. Okay, so we've got so student ID numbers. So I mean, they're not really too relevant, but they identify the subjects. So the hours studied, and then whether they passed or failed. Okay, so according to the data, it does seem like the students who studied more on average did pass the exam more frequently. Okay, so we'll go down. So based on the table, what kind of conclusions could you draw between the hours studied and passing the exam? We could think that if we have the data from hundreds of students, maybe we could see the amount needed to study in order to pass the course. We can present this data in a chart as you can see below. Okay, so we got logistic regression, exercise 19, and it looks like we got a bell curve over here, and I don't think we can adjust it. So hours studied, so why is there -5? Why do we go into the negatives for hours studied? I'm not really too sure. The probability of passing is over here from 0% to 100%. Oh, maybe it extends into the negatives because because it starts higher than 0 over here. Okay, so we got 100% chance of passing and then 0% chance of passing. But let's see. So hours have studied, but it looks like there's only 0% and 100%, because I guess in this case there's only pass or fail in our data set. Okay. So each dot on the figure corresponds to one student. On the bottom of the figure, we have a scale of how many hours the student studied for the exam, and the students who passed the exam are shown as dots on the top of the chart, and the ones who failed are shown at the bottom. We use the scale on the left to indicate the predicted probability of passing, which we'll get from Logistic regression model and as we explained just below. Based on this figure, you can see roughly that students who spent longer studying had a better chance of passing the course. Especially the extreme cases are intuitive. With less than an hour's work, it is very hard to pass the course, but with a lot of work, most will be successful. But what about those who spent time studying somewhere in between the extremes? If you study for 6 hours, what are your chances of passing? We can quantify the probability of passing using logistic regression. The curve in the figure can be interpreted as the probability of passing. For example, after studying for 5 hours, the probability of passing is a little over 20%. Okay, so 5 hours and 20%. So let's find this on the chart. Okay, so 5 hours is here, and if we go up and look at the curve, it is around 20%. So I guess to guarantee yourself 100% chance of passing, you need to study somewhere around 17 hours. 17 and a half hours is my guess. Okay, let's go back down. Okay, we will not go into detail about how to obtain the curve, but it will be similar to how we learned the weights in linear regression. If you wanted to have an 80% chance of passing a university exam based on the above figure, how many hours should you approximately study for? Okay, so we're looking for an 80% chance of passing. So if we go over here and we find 80% and then we go across, it looks like the number of hours is 10 hours. Brouhaha! Hello, nice to see you here. We're just doing our warm-up studying segment over here. If you want to take a look at the same stuff we're doing over here, we're learning about linear regression over at Elements of AI. So it looks like the number of hours we need to study in this case is going to be 10 hours to attain a pass rate of 80%. Okay, so that's why I didn't do great on my midterm, of course. Well, I mean, Tuna Piero, hello, nice to see you here as well. Yeah, so we're going to be switching topics in about 19 minutes, but for right now we're just doing our warm-up topic. We're learning about AI and statistics and machine learning, all sorts of great stuff like this. So it looks like we need to study around 10 or 11 hours to get an 80% pass rate. Let me double check that. So we want to get 80% pass rate. So that's slightly below 9 hours, slightly below 10 hours. So it's like 9 point something. Okay. If you wanted to have an 80% chance of passing the university exam, 10 hours, so it's below 10 hours. No, it's above 10 hours. It's above 10 hours. Okay, so it has to be above 10 hours. So 10 to 11 hours. We'll submit this. Okay, correct. The other answers give roughly a 30, 50, and 70% chance of passing respectively. To have an 80% chance of passing, you should study for around 10 to 11 hours. Okay. And let's see. Bruja says, I've been making my own website using only HTML and CSS. Pretty fun, actually. Hope you're having a lot of fun doing that. And Space Rebel, hello, nice to see you here. Hope you're having a good time. We're currently learning about AI stuff, and we'll be moving on in about 17 minutes. Logistic regression is also used in a great variety of real-world AI applications, such as predicting financial risks, in medical studies, and so on. However, like linear regression, it is also constrained by the linearity property, and we need many other methods in our toolbox. We'll return to the linearity issue later when we discuss neural networks. Okay, the limits of machine learning. To summarize, machine learning is a very powerful tool for building AI applications. In addition to the nearest neighbor method, linear regression, and logistic regression, there are literally hundreds, if not thousands, of different machine learning techniques, but they all boil down to the same thing. Try to extract patterns and dependencies from data and use them either to gain understanding of the phenomenon or to predict future outcomes. How does this correlate with AI? Well, the AI is, the way LLMs work is that they're prediction machines. So what they do is they try to figure out what the correct answer is by taking in all their training data and giving you the answer that is most likely to be correct based on all of their prediction. So, I mean, I'm not exactly sure about all of the nuts and bolts about how the LLMs work, but from what it was explained to me, you're so cool, this is super motivating. Well, I'm glad you're getting something out of it. So if we go over to the Google search bar over here, if I start typing in something, how do you something something, and then they do a predictive autocomplete over here, how do you something something. So based on the previous search results, how do you get strep throat, how do you get pink eye, how do you get kidney stones? So these are the most likely results after you type in how do you something something. Okay, so let's see. Oh, I see, thanks, okay. And they use datasets to determine the most likely token to come out next out of the pattern output. Yeah. But yeah, I mean, it's interesting to learn how the AIs work because people, they're not going to stop talking about AIs for a really long time, if ever, so we need to understand what's going on here. Okay, so machine learning can be a very hard problem, and we can't usually achieve a perfect method that would always predict the correct label. However, in most cases, a good but not perfect prediction is better than none. Sometimes we have to be able to produce better predictions by ourselves, but we may still prefer to use machine learning because the machine will make its predictions faster, and will also keep churning out predictions without getting tired. Good examples are recommendation systems that need to predict what music, what videos, or what ads are likely to be of interest to you. The factors that affect how good a result we can achieve include the hardness of the task. In handwritten digital recognition, if the digits are written very sloppily, even a human can't always guess correctly what the writer intended. The machine learning method. Some methods are far better for a particular task than others, and the amount of training data. From only a few examples, it is impossible to obtain a good classifier. And the last thing we need to understand is the quality of the data. Alright. So data quality matters. So in the beginning of the chapter, we emphasized the importance of having enough data and the risks of overfitting. Another equally important factor is the quality of the data. In order to build a model that generalizes well to data outside of the training data needs to contain enough information that is relevant to the problem at hand. For example, if you create an image classifier that tells you what the image given to the algorithm is about, and you have trained it only on pictures of dogs and cats, it will assign everything it sees as either a dog or a cat. This would make sense if the algorithm is used in an environment where it only sees dogs and cats, but not if it is expected to see boats, cars, and flowers as well. we'll return to the potential problem caused by biased data. Okay, so it is also important to emphasize that different machine learning model methods are suitable for different tasks. Thus, there is no single best method for all problems, one algorithm to rule them all. Fortunately, one can try a large number of different methods and see which one of them works best in the problem at hand. This leads us to a point that is very important but often overlooked in practice: what it means to work better. In the digit recognition task, a good method would of course produce the correct label most of the time. We can measure this by the classification error, the fraction of cases where a classifier outputs the wrong class. In predicting apartment prices, the quality measure is typically something like the difference between the predicted price and the final price for which the apartment is sold. In many real-life applications, it is also worse to err in one direction than another. Setting the price too high may delay the process by months, but setting the price too low will mean less money for the seller. And to take yet another example, failing to detect a pedestrian in front of a car is a far worse error than falsely detecting one when there is none. Okay? So as mentioned above, we can't usually achieve zero error. Perhaps we will be happy with error less than 1 in 100 or 1%. This too depends on the application. You wouldn't be happy to have only 99% safe cars on the streets, but being able to predict whether you'll like a new song with that accuracy may be more than enough for a pleasant listening experience. Keeping the actual goal in mind at all times helps us make sure that we create actual added value. After completing Chapter 4, you should be able to explain why the machine learning techniques are used, distinguish between unsupervised and supervised machine learning scenarios, and explain the principles of 3 supervised classification methods: the nearest neighbor method, linear regression, and logistic regression. I'm not too sure if we've got the follow age or watch time on this channel, Space Rebel, but nice to see you here. Okay, so let's see. Join the Elements of AI community to discuss and answer questions about this chapter. So our correct answers could use a little bit of work, but we'll move on to the next chapter. Neural networks. So what is this all about? I mean, we hear about neural networks all the time, and I'm pretty sure that the current type of LLM AI technology is also based on neural networks. So we'll figure out if we're correct in just a second. Okay, so this is Chapter 5. There's only one chapter after this one. I missed the whole live again. I wouldn't say that you missed the whole live, Cypher, but we have been at this for about an hour or so. Okay, so, but Cypher, you could go back to the beginning of the recording if you wanted to, and then, you know, you can set the speed to like 2 times if you wanted to catch up. Anyways, let's talk about neural networks. So areas like natural language and image processing have traditionally been sore points of AI. Neural networks and deep learning are being used to achieve significant improvement in these areas. In Chapter 5, we'll cover the following sections. Click below to get started. We've got neural network basics, how neural networks are built, and advanced neural network techniques. So let's go ahead and start the first section, neural network basics. Okay, so our next topic, deep learning and neural networks, tends to attract more interest than many of the other topics. One of the reasons for this interest is the hope to understand your own mind, our own mind, which emerges from neural processing in our brain. Another reason is the advances in machine learning achieved within the recent years by combining massive data sets and deep learning techniques. Okay, Space Rebel, I'm interested to see if you can redeem that, because I think I've seen that some people on YouTube haven't been able to redeem the stuff from the CloudBot. But anyways, I'll redeem it for you. Does it go through? Huh. Am I not able to do the redeems either? It seems like the bot has is kind of wonky. Hold on, let me turn off the bot and turn it back on again. And then turn it back on. Okay, and then bot's on strike. Yeah. Okay, let's redeem the Stiller's J. Here we go, okay. Alright. Anyways, let's continue. Okay, so what are neural networks? To better understand the whole, we can start by discussing the individual units that make it up. A neural network can either mean a real biological neural network, such as the one in your brain, or an artificial neural network simulated in a computer. Okay, so we got deep learning. Whoa, okay. Deep learning it refers to certain kinds of machine learning techniques where several layers of simple processing units are connected in a network, so the input to the system is passed through each one of them in turn. This architecture has been inspired by the processing of visual information in the brain coming through the eyes and captured by the retina. This depth allows the network to learn more complex structures without requiring unrealistically large amounts of data. Okay, so that's deep learning, and we've got neurons, cell bodies, and signals. A neural network, either a biological one or an artificial one, consists of a large number of simple units, neurons, that receive and transmit signals to each other. The neurons are very simple processors of information, consisting of a cell body and wires that connect the neurons to each other. Okay, we got ads running on Twitch right now, so when ads run on Twitch, I'll also take a little break so that nobody misses anything, and we'll put on the birds. How about... How about these birds? Okay, so enjoy the birds. We'll be back in about 60 seconds. Where's that bird? Here it is. Okay, we'll be back in about 50 seconds, but enjoy the music and enjoy the birds. Bruhaha asks, are these your birds? I wouldn't say that they're my birds. They're the birds in my neighborhood. And this is security footage that I captured with my video camera. So they're not. This is my backyard, and these are the birds that come into the backyard to enjoy the bird bath. Stasix asks, are you getting lots of birds with the nicer weather? Yeah. There's a lot of birds that come by now. Actually, the birds enjoy coming to the bird feeder when the weather's bad. So when the weather's bad, they get super hungry. But when the weather's nice, they don't come around as often. They're Vancouver birds. Yeah, I guess so. I guess you could say that. Anyways, let's put the birds away. We'll get back to... Well, I mean, we're basically done. But before we go, I guess we'll continue talking about these neurons and cell buddies. So the neurons are very simple processors of information, consisting of a cell body and wires that connect the neurons to each other. Most of the time they do nothing, but sit still and watch for signals coming through the wires. Okay, we got, this seems a lot more like biology, more than software right now, but I guess we're using the software to make up a model that that includes stuff like this. So neuron cell bodies and signals, and we got dendrites, axons, and synapses. So this is all terminology that I remember from biology class way back when. Okay, so in the biological lingo, we call the wires that provide the input to the neurons dendrites. Sometimes, depending on the incoming signals, the neuron may fire and send a signal out for other neurons to receive. The wire that transmits the outgoing signal is called an axon. Each axon may be connected to one or more dendrites at intersections that are called synapses. Computerology, I guess so. So isolated from its fellow neurons, a single neuron is quite unimpressive and capable of only a very restricted set of behaviors. When connected to each other, however, the system resulting from their concerted action can become extremely complex. To find evidence for this, look no further than, to use legal jargon, Exhibit A, your brain. Wow. The behavior of the system is determined by the ways in which the neurons are wired together. Each neuron reacts to the incoming signals in a specific way that can also adapt over time. This adaptation is known to be the key to functions such as memory and learning. Okay, so we have no chance of answering this question in about a minute. But what is this? Elements of a neural network. So label the different components of the neuron in the diagram below. Hint: the input of the neuron comes from the left and the output goes to the right. Okay, I feel like I'm back in biology class. So we got B, D, B, A, C, D. Speed run, let's go. 30 seconds, huh? Okay, so B is the thing at the beginning, which receives the signals. So what receives the signals? The wires that provide input to the neuron dendrites. We call the wires that provide the input to the neuron dendrites. So B has to be dendrites. So B is dendrites. Okay, and then A is the actual neuron itself. So the cell body. So the cell body is A. And C is... What are our options? So the synapse, the connection, and the axon is the output. So the axon is the thing at the end. So the axon is D. Axon is D, which means that this has to be the synapse, or the connection. Or A and C could be flipped around. Anyways, we'll submit this. Okay, so we mixed up D and C. So the synapse and the cell body were flipped around. Anyways, we'll come back to this. We'll come back to this next time. But thank you very much for coming by for the warm-up. But what are we doing next? So we're going to be doing a series of demonstrations over at Scilab, which was formerly called PicoCTF. So if you don't have an account over at Scilab, but you do have one over at PicoCTF, I'm pretty sure you can use the same login. But before we get started, I need to close out some of the windows that I'm not using. We're doing topic number 2. Topic number 3 is on deck. And we're doing general category challenges from PicoCTF 2026. So if you're logged in and you want to follow along with the stuff we're doing, then you want to take a look at this webpage right here. Okay, so let me go ahead and pull up our first challenge. So the first challenge is going to be Bytemancy 0. Let me pull it up. Bytemancy 0, okay. General skills. This is the URL for the challenge if you want to follow along. And I'll be doing a demonstration of these challenges and also talking about the funny little pieces of technology that we encounter while we're solving these. Alright everybody, this is a guided walkthrough for the Bytemancy 0 challenge over at PicoCTF, otherwise known as Scilab Academy. And the description for the challenge says, can you conjure the right bytes? The program's source code can be downloaded here. So they've got a link, and it says additional details will be available after launching your challenge instance. So we're going to launch the challenge instance over here by clicking on the button, and then the challenge instance is going to start. So if we wanted to connect with the program, we need to use this Linux command right over here. So netcat to a specific server on a specific port. So if we grab the command over here, so just highlight it and then select copy, right click, select copy, then we go over to our web shell. What we're going to do on the web shell, which is a Linux virtual machine that we can use to solve these challenges, we're going to create a directory to work inside of. So I'm going to make a directory called byte0, because the name of the challenge is Bytemancy 0. We're going to enter the directory, and then we're going to download the script file that runs the application. So to do that, we can type in the word wget and then space, and then right-click, select paste. Oh, that's not the script file. Okay, so what this is this is a netcat command that we can use to contact the challenge. So when we run this, we see this output over here. So this is Bytemancy 0, and it says send me ASCII decimal 101, 101, 101, side by side, no space. So what does this mean? Let's talk a little bit about this before we solve the challenge. Okay, so this is PicoCTF 2026. The name of the challenge is Bytemancy 0. In this challenge, they want us to conjure the right bytes. But what does this mean? Okay, in this case, what we're dealing with is something called ASCII bytes. So we're given a Python script to inspect. So they had a link. So the program source code can be downloaded here. So they had a link over here, and what we can do is we can right-click on it and then select copy link. Then go back to our web shell, and we can download it. So we type in wget and then space, and then right-click, select paste. So this will paste in the file address. So when we give this whole command, it's going to download the app.py file. So app.py is in here now. What we're going to do is we're going to inspect it using the nano text editor. So nano space app.py. Okay, Mr. Cowboy says, why don't you do pwn challenges? I do pwn challenges every once in a while, but the pwn challenges are not really on the schedule today. Okay, so the script that runs the program is right over here, and what it does is it prints out the message. So send me ASCII decimal 101, 101, 101, side by side, no space. So what does ASCII decimal 101 actually mean? We'll talk about that in just a second. So it also does a little check over here, so our user input. The user input is the stuff that we type into the program, and if the user input is equal to hexadecimal 656565, so we know this is hexadecimal because there's a /x in front of the number over here. So this is a hexadecimal number, not a regular decimal number. So if it is hex 65, hex 65, hex 65, then print out the flag.txt file, and then that finishes the program. So else, this is what I got, and then it gives you your input. So what's actually going on here? They talk about hexadecimal 65, they talk about decimal 101. What does this actually mean? So we're given a Python script to inspect. The key part of the script is that if we send specific bytes as the user input, the flag.txt file contents will be read to us. And remember, typically in any one of these CTF challenges, we want to get the contents of the flag. Okay, Mr. Cowboy asks, what did your CTF skills translate to in the real job market? The CTF skills don't, well, I mean, the CTF skills sometimes deal with real-world programs that professionals use. So if we're talking about digital forensics, we deal with Wireshark, which is a very common program that is used in network forensics, trying to look through network packet files. So sometimes the CTF challenges deal with real-world software that is used by professionals. And sometimes they're just talking about technology in a very general way, which beginners need to understand. In this case, we're talking about ASCII bytes, and for people who don't understand what ASCII bytes are, this is something they need to learn if they want to continue their journey into technical roles. Okay, so the key part of the script is that if we send specific bytes as user input, the flag.txt file contents will be read to us. So these two numbers, decimal and hexadecimal, refer to ASCII encoding. For x65, the x refers to hexadecimal notation. Hexadecimal notation. Cypher says, done. Awesome, awesome. I'm glad to see that you're following along. Okay, decimal numbers or hexadecimal numbers can be encoded into ASCII characters. And the character associated with decimal 101 and hexadecimal 65 is the letter E. So the answer to this particular problem is the letter E 3 times. Memes, hey, what is up? Nice to see you here. Okay, so if we go back to the web shell, we're just going to exit from the challenge by doing Control X instead of nano. That'll exit us out of the nano program. So what we want to do is we want to access the challenge one more time with the netcat command. So we're just going to copy the netcat command one more time. I'm going to go to the web shell, we're going to paste in the command, and we're going to give the program ASCII decimal 101. So one more time, the numbers can translate out to ASCII characters. If we were to look up something like the ASCII table, we could get a table to look up as well. Okay, so let's visit this, and then we'll open up this graphic in a new tab. Okay, so we got our ASCII table over here, and remember, we're looking for a decimal 101. If we look up on the table, the character for 101, it is also the hexadecimal character 65, and it is the character lowercase e. So we'll go back to our web shell, we will give EEE, because that's what the program is looking for, and then we will submit this. Okay, and then we get the flag. So PicoCTF printable characters. So what you want to do to finish the challenge, copy the flag, then go back to the challenge, and down at the bottom, there's a flag submission field. So click into that, paste in the flag, and then click on Submit Flag, and you're finished. It says correct flag, you're done. Alright everybody, this was a guided walkthrough for the Byte Nancy Zero Challenge from PicoCTF, now known as Scilab Academy. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, let's move on to the next challenge. So we have a ByteMancy 1 challenge as well, which is a sequel to this one. So we'll click on that one. Let me grab the file for that, and we'll get started. Alright everybody, this is a guided walkthrough for the ByteMancy 1 challenge from PicoCTF, now known as Scilab Academy. The description for the challenge says, can you conjure the right bytes? The program source code can be downloaded here. And let's see, additional details will be available after launching your challenge instance, so we can go ahead and launch the instance, which is going to start the challenge for us. So in the meantime, what we can do is we can download the program's source code from the link over here. So highlight the link, right click, select copy link, and then go over to your web shell. Inside the web shell, what we're going to do is we're going to create a directory where we can store our challenge files. So we're going to make a directory called byte2, byte1, and then we will enter that directory. So from here, what we're going to do is we're going to download the script file. We type in wget space and then paste in the file address. So right click, select paste, and then hit enter to download the file. Okay? So after that, we'll have the app.py file in our directory here. Just a second, everybody. So to anybody who wants to do this challenge themselves, here's the link. I don't know if I put it in chat before. I think I did. Okay, so we'll go back to the web shell. Nano space app.py to open up the script file in our Python editor. Okay, so very similar to the previous challenge. There's a message printed out over here. So send me ASCII decimal 101 1,751 times, side by side, no space. So this is essentially the same thing that we did in the previous challenge, but we're increasing the number of characters that we're sending. And we can see the same thing over here. If user input equals hex 65 times 1,751, then open flag.txt and read it. Otherwise, print out that wasn't it, I got something something. So what's actually going on here? We'll talk about it. Okay, so this is PicoCTF 2026 ByteMancy 1. So in this challenge, like the previous one in this series, they want us to conjure the right bytes. But what does this mean? Time for a loop. Not exactly a loop, but they're looking for just a lot of characters. So doing it manually is going to be a big pain in the butt, but well, we can use Python to print these characters out for us as well. So we're given a Python script to inspect, and we see that we need to give the same character that we gave for the previous challenge, ASCII decimal 101, which is the lowercase e, but we need to give it 1,751 times. So the key part of the script is that if we send specific bytes as user input, the flag.txt file, contents will be read to us. So it's hex 65, yeah, a bunch of times. So like the previous challenge, we need to send a certain byte, which is the same byte as the previous challenge, but repeated 1,751 times. So hexadecimal numbers can be encoded into ASCII characters, and the character associated with hexadecimal 65 is the letter E. So they're asking for hexadecimal 65, decimal 101, that's the lowercase e. So to send the exact number of characters, we can use a Python command. So I'll teach you the Python command right about now. So if we go over to our web shell, and what we're going to do is we're just going to exit out of here. So Control X to exit. That's what I meant in a programming for loop. Oh, yeah. So what we're going to do is we're going to use Python to create that large number of e's. So python.c is going to run a Python command. So the Python command we're going to run is the print command. So print, well, we can actually do the same thing that that they did in the scripts. So \x65, that's the letter E. Or we can actually specify the letter E over here as well, because either one of these things is going to get us our letter E. So if we print E, that results in, well, the letter E being printed out. But we can also print out /x65, and that produces the same expected character after line continuation character. Okay. Can we put... okay, we need to put this between some quotes. So if we put that between some quotes, then we get the letter E as well. So what we need to do is we need to produce 1,751. Okay, how could I forget about today's stream? No worries, SysOS. Nice to see you here. Hope you're having a good day. Okay, so we'll give the same Python command, but we're gonna multiply it by 1,751. So this is the command right here, Python C, which does a Python command. Print hex65, which is the lowercase letter e, 1,751 times. Okay, and this produces the right amount of e's. So if we were to do this manually, we wouldn't want to do this because it's too many e's to count. What we're going to do is we're going to pipe this into the command to the server. So how do we do that? Let me demonstrate. So we're going to run the same command, space, and then the pipe character. So whatever we output from the Python command, we're going to pass as input to the second command, which is our netcat command. So over the challenge, we're given a netcat command that we can use to access the server. So highlight it, copy it, and then go over to the web shell. Paste in the command. So what we have here is a Python print command that prints out many letters E, and then we pipe it into a netcat command that actually accesses the server. When we give this command, then we get our result. So PicoCTF, how many E's? So to finish the challenge, we're just going to copy all this. We're going to go back to the challenge description, and then we're going to submit the flag down here. So PicoCTF, how many E's? Click on submit flag, and then you're finished. Okay, everybody, that was a guided walkthrough for the Bytemancy 1 challenge from PicoCTF, now known as Scilab Academy. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons in the video and leave a comment underneath the video. But until next time, HackerFrogs out. Space Rebel says that looked way too easy. I mean, it's all about knowing what to do and understanding what exactly the challenge wants you to do. But I mean, the difficulty of the challenges, it can vary pretty widely. So these are all challenges from the most recent PicoCTF event. SysOS Master says needs to be a string for print to work with. Yeah. Anyways, we'll move on to the next challenge. We've got like 3 more challenges to work through. So we'll do the undo challenge next. Okay, so before we do that, let me just go back to my web shell and do a little bit of housekeeping. So we're done with the byte 0 and byte 1 challenges, so I'm just going to remove those directories. Okay, and then we can continue. Knowing is the hard part. Yeah, I mean, learning about technology and learning about hacking is all about collecting a number of tricks. Understanding little pieces and learning little tricks, and eventually you'll be able to solve the challenges without having to get any hints. So that's the goal, of course. Alright, so the next challenge is the undo challenge. Let's go ahead and pull it up. undo. Here we go. Hard carry energy certified. You know your stuff? Well, I mean, I know enough to do these challenges. I wouldn't say that I'm an expert at any of this, but I mean, I teach what I know, and I know the basics. And if you know the basics, you can do this stuff. If you don't know the basics, that's fine. You just need to take a bit of time to learn the basics. All right, everybody, this is a guided walkthrough for the Undo Challenge from PicoCTF, otherwise known as Scilab Academy. So the challenge description says, can you reverse a series of Linux text transformations to get the original flag? So additional details will be available after launching your challenge instance. So what we need to do is we need to click on the launch instance button here to begin the challenge. So after it's done, we're given a command to run on our Linux terminal. So NC for netcat, and we've got a server to contact, foggycliff.picoctf.net, and a certain port, 50,000 something something. So what we're going to do is we're going to copy this command, and then we're going to go over to our web shell. So in the web shell, we can paste in the command, and then we can start the challenge. So right-click, paste, and then hit enter. Okay, welcome to the Text Transformations Challenge. Your goal, step by step, recover the original flag. At each step, you'll see the transformed flag in a hint. Enter the correct Linux command to reverse the last transformation. So the first thing we see is the current flag value. So the current flag value is a bunch of numbers and letters, and this has been encoded. We've given the hint that base64 encoded the string. So what we need to do is we need to use a base64 command to decode this string. So it says enter the Linux command to reverse it, and I guess we'll talk about this first part. Okay, Stosic says make a directory for this challenge. So we're not actually storing any files for this challenge, so that's why we didn't create a directory for this one. So in this challenge, we're asked to reverse some text transformations to get the flag. So the first thing that we're doing in this case is we're doing some base64 encoding and decoding. When we connect to the server, we're asked which Linux command will base64 decode a string. So base64 is a system of encoding that transforms data into a string of characters that includes uppercase and lowercase letters, numbers, and a couple of special characters like the plus symbol and the slash symbol. So if you see a string that has this set of characters, then you might be dealing with something that was encoded using base64. There's a method to the madness. Well, I mean, we don't want to do anything unnecessary in this case. Alright. So with Linux, we can use the base64 command with the -d argument to decode base64 strings back into their original contents. So if we had this string over here, and we wanted to decode this, we could use base64-d to get the original contents. So I'll do a little demonstration over here. So if we echo something out, HackerFrogs, okay, and we wanted to encode this using base64, we would pipe this into base64, and then we get this string over here. So one telltale sign that you're dealing with base64 encoded strings is that you might see a couple of equal signs at the end of the strings. So this is a pretty big clue that you might be dealing with base64 encoded information. If we wanted to decode this, we would take the same string and we would echo it out again, but then run it with the base64 decode command here. And we get the original string back. Alright, so with that said and done, we'll go back to the challenge, enter the Linux command to reverse this. So the Linux command to reverse this is base64-d for decode. SysOS Master says you can also try base64 and from hex on any string that you suspect holds data. Yeah, I mean, in a lot of like especially beginner level CTF challenges, you're going to encounter base64 a lot, so it's a very useful skill to know how to decode it. Okay, so give the command, and then it says correct. So step 2, current flag is this. All right, and what we need to do is we need to reverse the text. So enter the Linux command to reverse this. So what we're dealing with is a very simple string reverse. So if we go over here and we echo out HackerFrogs, and then we pipe it into the rev command in Linux, this is going to print out the string backwards. So this is HackerFrogs backwards. If we wanted to restore this, we'd echo out the same thing and then pipe it into rev again, because the opposite of rev is also rev, and we get our original string. Okay, so we'll go back, and what we're doing here is called string reverse. The next step in the challenge requires us to reverse a string. That is outputting the string contents in reverse order. So reversing a string in Linux is easy with the rev command, rev. Okay, let's go ahead and do that. Go back to the web shell and enter the Linux command to reverse this. rev for reverse, hit enter, and then we've got step 3. So the current flag looks like this, and it says hint replaced underscores with dashes. Replaced underscores with dashes. So we see a dash over here, 1, 2, 3, 3 dashes. We need to replace these characters with underscores. So the dashes replaced with underscores. What we can do is we can do something in Linux called tr translate. So if we were to echo out HackerFrogs, exclamation point, and we wanted to replace the exclamation point with a question mark, we could use the tr command. So tr is going to replace one character with another, or a pattern of characters with another. So in this case, we're going to replace the exclamation point. Actually, we need to put this between some single quotes. We're going to replace the exclamation point with the question mark. So when we run this, it'll replace the exclamation point, and it's going to put the question mark there. Okay. HackerFrogs? Question mark? Okay. So in this case, what we need to do is we need to do character replacement. The next step in the challenge is to replace the dashes in the string with underscores. So this is a dash, this is an underscore, we need to replace these. The Linux tr command can be used to replace characters and strings. The first argument to the command are the characters to target, and the second argument to the command is the characters that change the target to. So if we were to replace the word Pico with frog from PicoCTF, then we would get frog CTF, because the tr command replaces the word Pico with the word frog. Be careful with the exclamation point in the shell, it has meaning and can act weirdly. Yeah, that's the wonderful world of Linux that we're dealing with here. Okay, so let's go ahead and run the command on the web shell. So in the web shell, type in tr space, and then between some single quotes, replace dashes with underscores. And make sure to place the dash and the underscore characters between these single quotes. Otherwise, weird stuff could happen. Anyways, give the command, and it says correct. So the current flag is this, and it says hint replace curly braces with parentheses. So we have our parentheses here and here. We need to replace these parentheses, and we need to put curly braces in their place. So we can use the same command that we used earlier, so it's tr. But in this case, we're going to put a set of characters. So these parentheses, the left and the right, we're going to replace them with the curly braces. The left and the right curly braces, like this. Okay, so give this command, and And Zevatron, hello, nice to see you here. What is up? And we've got our last step over here. So the current flag is this, and it says hint, applied rot13 to letters. Enter the Linux command to reverse it. Okay, so in this case, we're dealing with another type of encoding, encryption and decryption in this case. So the method is called rot13. The last step asks us to apply a rot13 transformation to the string. So rot13 is a specific type of an encryption. That is, it's a specific application of the Caesar cipher. So rot13 encryption is a common application of the Caesar cipher, a classical encryption method, where the letters in a string are shifted a number of letters to form a ciphertext. So when you do rot13 encryption, anytime the letter A appears, you replace it with the letter N. Anytime the letter B appears, you replace it with the letter O. And vice versa, if you've got the letter N, you replace it with the letter A, and you do this to all the letters in the plaintext to form something called the ciphertext. Okay, Zevatron asks, why is one of the stream tags HackMyVM? HackMyVM is a cybersecurity education platform you use on a pretty regular basis, but not every day. If you want to, you can look up the platform and you can try some of the challenges over there. Okay, so what we need to understand is that we can also use the tr command in Linux to perform a rot13 transformation, since we are replacing certain letters with others. So let me go ahead and get the command, because it's a bit long. So the command we're looking for kind of looks like this: tr, capital letters A to Z, lowercase letters A to Z, replace them with capital letters N to Z, and then A to M, and then lowercase letters N to Z, and then A to M, like this. Okay, Zevatron says, are you going to do any real hacking or just learning? I don't know if, I don't know what you define as real hacking, Zevatron. Could you let me know what quote-unquote real hacking is? We're mainly an education channel. We do all sorts of education exercises. We don't do anything illegal. So if you're asking me to hack hack Instagram or hack Facebook, I'm afraid I can't do that. Okay, SysOS Master says it's 2 times 26 letters long plus a bit, so a bit long. Okay, so if we run this command, we need to give the tr command something to transform first. In this case, we're going to do HackerFrogs like and subscribe, so this message over here. Then we're going to apply the rot13 transformation over here. So we get this message. So this is the encrypted message. So to decrypt this message is pretty easy. We just need to echo out the original message again, and then give the tr command. Okay, and then we can get the original message back. Okay, so Zevatron says, I mean like hacking a contained VM on TryHackMe or HackTheBox? I mean, we are going to be doing a TryHackMe room later on today at the end of the stream. This is the one over here. We're going to be investigating the copy fail vulnerability. Okay, Victor86 says, I bought a humble bundle video of IT Pro videos. Too many videos. How am I going to watch that many videos? Over many days, maybe. But Zevatron, we do like CTF box challenges. We don't do them every day, but maybe like once or twice, maybe like once a week. You can take a look at the previous VODs if you want to investigate that. Anyways, so we're going to grab this command over here, the tr command that does the rot13 transformation, copy that, go back to our web shell, and then we're going to paste that in, and that's the end of the challenge. Congratulations, you've retrieved the original flag. PicoCTF reversing the text transformations. So we're just going to copy this command here. Space Rebel says, I'm not a hacker, just here for the lives. Everybody's welcome, as long as you don't act like a jerk. That's all. Let's see. Victor86 says, can people see my comments via search on the internet? See your comments via search on the internet. I mean, it depends on where you left your comments. Are you talking about Facebook? Are you talking about Instagram? They might be able to search it up, depending. Okay, so we'll go over to the challenge. Click on this flag submission field here, paste it in, click on submit flag, and you're done. Victor86 says, what happened to Dirty Frag? So, I mean, Dirty Frag is another thing that we could cover over at TryHackMe. They released a room, I think it was like today, and I think we're going to be covering that on Friday. So copy fail is here, Dirty Frag is going to be on Friday, and yeah, apparently they're related vulnerabilities. Alright everybody, that was a guided walkthrough for the Undo Challenge from PicoCTF, now known as Scilab Academy. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons in the video, and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, Stasic says, Dirty Frag is newer than CopyFail. They're in the same class. Oh, okay. It's good to know. Alright, so let's go ahead and move on to the next challenge. So the next challenge, I think... Let me see if I can grab it. Hold on, I need to look up my walkthroughs again on my GitHub. So if you're interested in seeing the, taking a look at the GitHub for HackerFrogs, you can find it over here. PicoCTF 2026 General. The next challenge is going to be multi-code. Okay, so multi-code is a very similar challenge to the previous one. Let me pull it up. Multi-code. There we go. Alright everybody, this is a guided walkthrough for the multi-code challenge from PicoCTF, otherwise known as Scilab Academy. So the description on the challenge says, we intercepted a suspiciously encoded message, but it's clearly hiding a flag. No encryption, just multiple layers of obfuscation. Can you peel back the layers and reveal the truth? Download the message. So, in this case, what we need to do is we need to download the message, and we need to decrypt it, or decode it, to get the flag. Stasic says, I'm off to get something to eat. Have fun with the challenges, Frog. Thank you very much, Stasic, and hope to see you next time. Okay, so we have a link over here, and what we're going to do is we're going to copy the link. So right-click, copy link, then go over to our web shell. And in the web shell, we already have a multi-code directory here that we created. So we're going to enter that directory. And we've got our message over here. So message.txt. So if you hadn't done this, what you want to do is you want to use the wget command. Wget space, right click, paste in the file address, and then this command is going to download the file. But we already have the file downloaded, so we're going to read the message.txt file. So cat message.txt, and what we see is a very long string. So if you're familiar with CTF challenges, you might be able to predict what kind of transformation this is, or sorry, what kind of encoded string this is. So we've got numbers and letters, uppercase and lowercase, some numbers, and an equal sign at the end. So let's talk about this. So in this challenge, we're asked to decode multiple layers of encoding to read the flag. Base 64, yeah, our something you see over and over again. So the first layer of encoding in this message is base 64 encoding. So base 64, this encoding system takes data and encodes it into a text string with uppercase and lowercase letters, numbers and a couple of special characters, the plus symbol and the slash symbol. InfoSec Forever has just subscribed with Prime. Thank you very much, InfoSec Forever, for your subscription on Twitch. That is much appreciated. Let's give you a fun video clip just for that.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Okay, so InfoSec Forever, yeah, we're talking about Scilab. Scilab is the rebranding of PicoCTF. So if you know PicoCTF, then you probably know most of what Scilab is. But the new website is over here. Okay, so let's see. Victor86 says, I worry when you paste a command in that it won't respond because of electricity failure. Does that ever happen, or could? When you paste a command in, it doesn't respond because of electricity failure. Electricity failure? InfoSec Forever says, I just signed up, it looks awesome. Yeah, I mean, PicoCTF, Scilab now, it's one of the best free resources you can use to learn about different cybersecurity topics. So definitely, I hope you have a lot of fun with those challenges, because there's a lot of them, and they're really, really good. Okay, so let's talk about this, what we're doing. So we can use the Linux base 64 command to decode the string. So we've got the string over here. So if we read the message, we see this. But what we want to do in this case is we want to pipe this into our next command. So command piping is basically passing the output of one command into the input of another. So we cat message.txt, then we use the pipe. So the pipe character on American keyboards is the shifted version of the backslash. Then you type in base 64 -d for decode. That's going to decode the base 64 string. And what we see next is this, a bunch of numbers. And if you see a bunch of numbers that you think might be some sort of special code, I think the most important thing about these numbers is that we see some letters here as well. So we see the letter F, and if we see numbers and letters that are very limited in their scope, the letters will never go beyond the letter F, for example. This could be an example of hexadecimal numbers. So what are hexadecimal numbers? So the next step is hexadecimal ASCII encoding. So the resulting output is a string of numbers and letters, which appears to be hexadecimal digits. This points to hexadecimal ASCII encoding. So what we can do is we can try to decode this. ASCII encoding is an encoding system where strings of numbers are converted into ASCII characters and vice versa. So if we were to echo out ABC and then use a program to encode this into hexadecimal characters, then we would get the numbers 41, 42, and 43. So these are not decimal numbers, these are hexadecimal numbers, because we're using the XXD program to get the hexadecimal output. Okay, let's see. SysOS says, I generally add a semicolon echo to base 64. It helps with the reading. Okay, Victor86 says, how many AI should I try out? Just avoid the government dangerous ones? I mean, I'm not really someone who has a lot of experience with AI, but go with whichever model is the best for you. I'm not too sure how to be more specific than that. Okay, so XXD is the program that we're going to be using to decode this. So XXD is a pretty common Linux command. If we run XXD-P, it's going to reverse Oh, no, 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 no. If we run xxd-p-r, it'll reverse from hexadecimal characters, and it's going to result in printable ASCII characters. So we'll go back to our web shell, and we're going to run the same command we ran before, but we're also going to pipe it out into another command, xxd-r-p. So we're going to reverse the hexadecimal encoding, and we're going to print it out as we're going to print it as a single string. So in this case, this is the result over here. So this is even more encryption that we need to do here. Specifically, we need to get rid of, well, we need to address these characters right here. What are these characters? Let's talk about this. Okay, using Linux, we can convert hexadecimal characters to ASCII and vice versa with the XXD program, which we just did. And the next step we need to do is we need to do URL encoding. So now the output string looks like it's been ROT13 encrypted, but there's also some URL encoded characters in the string. So we see %7b and we see %7d. So what are these characters? So URL encoding is applied, this is an encoding method that is applied to web addresses and transforms characters that are usually not allowed in URLs. So a lot of special characters like the $, the brackets, single quotes, etc., spaces. It's going to convert those into a % symbol followed by 2 hexadecimal digits. So % something something. For example, %20. So the 2 hexadecimal digits used with the % sign in URL encoding map directly to the hexadecimal digits for ASCII encoding. So in this case, ASCII encoding hex for 1, URL encoding % for 1, this is associated with the capital A character, or hexadecimal hex 20 or %20, this is associated with the space character. Okay, on Linux, we can use the Python command to URL decode special characters back into their original forms. So using Python is the simplest way we can do this if we want to use the command line. So let's go ahead and do that. Okay, so we'll go back to the web shell. We'll run the same command that we ran before. We're going to pipe it into this Python command. And before we run the Python command, let's just talk about what the Python command is doing. Okay, so the Python command is this. Okay, so this is the Python command. So we run Python command import sys and urllib.parse. So these are two modules we need to use to run the command. And we're going to print out urllib.parse unquote system standard in read strip. So what this is going to do is it's going to convert any URL encoded characters back into their original forms. Okay, so we're going to go back to the command that we did before. We're going to paste in this Python command and then run it again. So that transforms the URL encoded characters, the %7b and the %7d, back into these characters, left curly bracket and right curly bracket. Okay, so the next thing we need to understand is that the resulting output looks like a CTF. Looks like a CTF flag that has been encrypted with a substitution cipher. How do we know that? We know that from the format. So if we take a look at the format of this string over here. So there's this, and then some curly brackets, and then some stuff in the middle. So if you know your PicoCTF flags, the PicoCTF flag format usually looks like PicoCTF, and then between some curly brackets, some stuff here. So it looks something like this. So this kind of pattern looks very similar to this. Okay, you got the Perl command. Awesome, awesome. Whatever command works for you, works for you. Okay, all PicoCTF flags start with PicoCTF, followed by some contents between a pair of curly braces, which is very similar to what we see over here. So the most common substitution cipher used in cybersecurity challenges is ROT13, the simplest application of the Caesar cipher. So in ROT13, if you've got a capital letter A, you turn it into a capital letter N, and if you've got a capital letter N, you turn it into a capital letter A, and you apply this transformation to everything in the string. So in ROT13 encryption, each letter of the ciphertext or the secret message is rotated by 13 positions in the alphabet to form the plain text, which is the original message. For example, the letters ABC would become the letters NOP and vice versa. So in Linux, we can use the tr command to apply the ROT13 encryption and decryption operation and get the fully decoded flag. So the tr command can be used to transform one set of characters into another set of characters. So let's go ahead and do that. Go back to our web shell. We're going to give the same command we did previously, hit up to run the previous command, pipe it into the tr command over here. So tr, capital letters A to Z, and lowercase letters A to Z into capital letters N to Z, and then A to M, and then lowercase letters N to Z, and then A to M. When we run this command, we finally get our unencoded flag. So PicoCTF nested encoding, we can copy this flag, we can go back to the original challenge, and we can scroll down to the bottom and paste it into the flag submission field here. Click on Submit Flag, and then you're finished. Where'd that thing go? Okay. All right, everybody, that was a guided walkthrough for the multi-code challenge from PicoCTF, otherwise known as Scilab Academy. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, we've got one more challenge we need to cover before we're going to move on to the next portion of today's stream. So the last challenge we're going to be doing today is called sudo make me a sandwich. Sudo make me a sandwich. So the challenge is over here if you want to try this out yourself. And before we do that, let me go ahead and get out of the current directory. Okay. And I think I need to get my presentation file for this. So sudo make me a sandwich. Okay, let's start. All right, everybody, this is a guided walkthrough for the sudo make me a sandwich challenge from PicoCTF, otherwise known as Scilab Academy. The description for the challenge says, can you read the flag? I think you can. All right, so they've got a link over here to start the challenge. The obligatory xkcd. Yeah, InfoSec Forever says, if I was going to decipher ROT13, my go-to would be CyberChef, but the tr command is pretty cool too. I mean, the good thing about the tr command is that you can chain it with another command if you're doing it inside of Linux. It's one of those commands that you're gonna want to add to your repertoire, because in beginner level CTF challenges you're going to be seeing it a lot. But you are certainly welcome to use CyberChef or any other method to transform with ROT13. Okay. So the first thing we need to do is we need to launch the challenge instance. So there's a big button over here that says launch instance. We click on that. And then we're given in SSH command over here. So SSH, and then we're also given a password. So what we need to do here is we need to log into the server using the SSH program. So to do that, we need to grab this part of the command. So don't highlight using password, whatever, just this part of the command. So right-click copy, then go over to your web shell. Jang says, how are you today? PicoCTF at the moment? Yeah, we're just going to do one more PicoCTF challenge before we move on to the next part of the stream. But nice to see you here, Zheng. Nice to see you. Okay, so we go over to our web shell, and then we're going to paste in this command. So right-click, paste. So what this command does is it securely connects to the server as the CTF player user over here. So just hit enter, and then it's going to ask you, are you sure you want to continue connecting? So this is pretty normal for SSH. Just type in yes, and then it's going to ask you for the password. So the password is in the challenge description itself. So right after the SSH command, you're given the password. Highlight the password, right-click copy, then go back to the web shell. In the web shell, you need to paste in the password. When you paste in the password, you're not going to see anything appear. This is normal for Linux. So just paste in the password and then hit enter. And then Space Rebel says, one sudo away from enlightenment. Of course. Okay, so in this challenge, in our current directory, after we log in, we see flag.txt here. But if we do lsla to see the details about the current directory, we see that flag.txt is owned by the root user, which is not our user. Our user is CTF player. And we don't have read permissions on this particular file. Only the root user has read permissions with this file. So what can we do? If we try to read flag.txt, it says permission denied because we don't have the right permissions. So how do we get around this? So the name of the challenge here is called sudo make me a sandwich. And in this challenge, we need to ask the flag somehow. Sudo-l, yeah, that's certainly what we need to do. So when we arrive in the server, we check our current directory and we see that the flag file is here, but we can't read it since we don't have read permissions on the file. But if we check our sudo permissions with the sudo-l command, we can see that we can run sudo with the emacs command. So this is how you would do it. So back at the server, run sudo-l. So sudo-l is going to let you know if you can run the sudo command with any particular commands as our current user, CTF player. Okay, so Victor86 says, what is the hardest thing to learn in studies? What is the hardest thing to learn? I don't know if I can answer that question. What is the hardest thing to learn? The hardest thing to learn is lots of boring rote memorization. And the way I get around that is I try to do like more hands-on activities. So the great thing about cybersecurity is that the standard cybersecurity exercise, the CTF, is very hands-on, and it's all about applying knowledge in order to achieve goals. Okay, so we run the sudo-l command, and we can see that our user, CTF player, can run the following commands. So we can run as any user with no password the /bin emacs command over here. So we need to understand that we can run the emacs command as the root user, and the root user is the user that owns the who owns the flag.txt file here. So what does this mean? This means, so in Linux, the sudo command is used to run a command in the context of another user, usually the root user, which is also the super user. Let's see, InfoSec Forever says, did you make that PDF yourself or is it downloaded from Scilab? I made this PDF myself. I wish I could download them from Scilab, but Scilab doesn't give you Scilab doesn't give you this stuff. I made these for my demonstrations here. Okay, so the sudo command lets you run commands as the root user for one command at a time. And in this case, we can run out the Emacs text editor. So Emacs is a text editor like Vi or Vim or Nano. And in this case, we can use the Emacs command as root. So what we can do, because Emacs is a text editor program, we can read the flag.txt file that is owned by root if we run it with the sudo command. And this is how you would do it. So back at the server, you would type sudo bin Emacs. So that's the command that we can run as sudo. And we run it on flag.txt. So this is going to open up the flag.txt file with the Emacs text editor. So when we run this, we get our flag. So PicoCTF just sudo it. So to finish the challenge, what we'd do is we would copy the flag. And just for fun, I'll teach you how to exit the Emacs program. So to exit Emacs, it's Control X and then Control C, and that'll exit the program. Otherwise, you'd have to look it up. But anyways, it's Control X and then Control C to exit the program, the Emacs program. Go back to the challenge description over here and scroll down to the bottom. So there's a flag submission field over here, paste in the flag, and then click on Submit Flag, and you're done. Okay, everybody, that was a guided walkthrough for the sudo make me a sandwich challenge from PicoCTF, now known as scilabacademy.org. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs up. InfoSec Forever says, not gonna lie, I would have to look that up. I mean, I had to look it up. What I'm doing is just sharing my knowledge that I looked up. But because I've never dealt with Emacs before, I only know that Emacs is part of the text editor wars. So the text editor wars are a quote-unquote war that are going on between people who use CLI programs. The text editor wars. So the wars are between people who use Vi/Vim, people who use Emacs, and people who use Nano. But they don't really count. It's mostly text editor wars between people who use Vim and people who use Emacs. A flame war, it's pretty heated. Anyways, are you able to recommend subreddits like NetSec? I mean, I don't really use too many InfoSec subreddits. I just stick to my own. Riyadh Gamer says, can I play CTF with TryHackMe while I've learned and used Python with some basic networking skills and while I've learned networking better? Will that distract me? I mean, what I would say is that if you're studying one subject and you kind of get burnt out, you get a bit tired of the topic, maybe you could try switching over to other topics. So a change is as good as a break. If you get tired of studying one topic, switching to studying another topic is more productive than taking a break from studying altogether. What about gedit? Kwrite not as popular? I mean, I'm not too sure. I guess we could add any number of text editors to the text editor wars. Sure, we could add gedit to it and kwrite. There are a lot of different text editors, and which text editor you prefer to use is a very personal thing. Of course, everybody thinks that their text editor is the best one. But anyways, we'll move on to the next topic of today's stream. So the next topic, it's going to be 60 minutes, and we're going to be doing HackerFrogs AfterSchool. Topic number 3 is here. Topic number 4 is on deck. So HackerFrogs AfterSchool is a program that I designed for teaching people how to use basic cybersecurity topics across a bunch of different disciplines. And the topic that we're covering today is we're going to be talking about digital forensics and network traffic. Okay, do you think you could try some hard level ones next time? I mean, the thing we focus on is mostly beginner challenges. Sometimes we come across some intermediate challenges as well. But the ones that we're going to be covering next, they're going to vary in difficulty as well, of course. Okay, so let me just close out some of these tabs we're not using. And let me get the notes for today's HackerFrogs AfterSchool topic. And I guess we can put on a little bit of music as well. Go ahead and do that. How about some of this music? Let's go. Okay, so HackerFrogs AfterSchool, let me get my notes. So if you're wondering what links we're going to be using in today's session for HackerFrogs AfterSchool, we're going to be using these ones over here. So if you ever get stuck, you can get yourself unstuck by taking a look at this markdown file over here. So this is HackerFrogs AfterSchool Digital Forensics Network Traffic. This is the 3rd session of Digital Forensics. And hey there, HackerFrogs, this is the 3rd Intro to Digital Forensics workshop. In the previous workshop, we learned about the following digital forensics concepts. We learned about steganography. Steganography is the process of hiding information in another medium. For example, hiding a hidden message in a picture. When dealing with digital files, steganography can be used to embed files or messages into different media files, such as pictures, videos, and audio files. We also talked about steghide. Steghide is a program which can be used to embed files into certain types of picture and audio files. Embedding files with steghide can use password protection for added security. In this workshop, we're going to be talking about the following 3 topics. We're going to be talking about network logs, packet capture files, and the Wireshark program. So the first thing we're going to be talking about is network traffic. This workshop's topic is computer networking log forensics. Anytime a network device sends data from one device to another, network traffic is generated as network packets are sent back and forth. But when we say network device, what are we talking about? What is a network device? Any device that connects to a computer network, such as PCs, phones, tablets, cars, other IoT devices, etc., these are all known as network devices. We're also going to be talking about network packets and traffic, and network packets contain a number of elements such as source and destination. The network addresses of both the source and destination devices, their IP address. So we'll see a lot of IP addresses in this kind of format, so 4 octets, and one is going to be the sending device, and the other device is going to be the destination device that receives the traffic. We're going to be talking about the payload, the actual data that's being sent. So in the case of web traffic, the payload is the web page that is being transmitted. Okay, SysOS Master says, let's not forget about devices that make the network possible, such as access points, routers, and switches. That's all networking infrastructure, of course. Okay, so we can also send header info. This is the essential data for routing and processing the packet. So how the packets get to the correct destination is contained within the network packet header. We're also sending protocol info, depending on the type of data that the type of data packet that's being sent, be that TCP packets, TCP protocol, UDP protocol, HTTP protocol, etc. Protocol-specific data can also be included inside of the packet. So we'll also be talking about PCAP files. Files that contain a collection of network traffic are called packet capture, or PCAP files, and one specialty of digital forensics is the analysis of network traffic and PCAP files. So Wireshark is the common program that is used to inspect network packets in PCAP files. Wireshark is a program which is widely used for network traffic analysis, and we'll be learning how to use it to analyze PCAP files. Okay, so the module that we're going to be using to learn about Wireshark and PCAP files is on the TryHackMe website as part of their Advent of Cyber Day 9 module. So Advent of Cyber is a Christmas event, but the great thing about these modules is that they're accessible year-round, and some of them are very, very useful for learning about different cybersecurity concepts. So let me go ahead and get my notes. So this is the room that we're going to be using. You're going to need to have an account over at tryhackme.com in order to access this. But after you're logged into TryHackMe, then go over to the link I just put into the chat. If you don't have an account for TryHackMe, you can make one for free at this link over here. But let's go ahead and go to the TryHackMe room. So this one is Advent of Cyber 3 from 2021. So what we need to do is we need to go down to day 9. So if you haven't joined the room, what you want to do is you want to join the room and then scroll down to day number 9. So where is that going to be? Day number 9 is task number 14. So task 14, day 9, where is all this data going? So click on the task header over here. Okay. And what we want to do is we want to follow this task number 14. But before we do that, we want to get access to a machine where we can use Wireshark. So to do that, go back up to the top of the page, and at the top of the page, there's going to be a box labeled Start Attack Box. So this is going to give us access to a desktop Linux environment where we can run Wireshark. So scroll up to the top, then click on Start Attack Box, and you're going to see the web browser pane split into two. So the attack box interface is actually on the right hand side of the screen over here, and it's going to take about 2 minutes to finish loading up. But while that's going on, we can actually talk about what we're going to be inspecting inside of Wireshark. Okay, so before we get going, I'm going to give you a very, very quick and dirty breakdown of the OSI model. So this is Computer Networking Basics. Before we dive into how to use Wireshark, let's review the OSI model, which Wireshark uses to organize PCAP contents. So the interesting thing about Wireshark is that they organize their packets very closely to the OSI model. So the OSI model is a system for organizing computer networking data into abstract layers. There are 7 layers in the OSI model. So the OSI models are Layer 1, physical, Layer 2, data link, Layer 3, network, Layer 4, transport, Layer 5, session, Layer 6, presentation, and Layer 7, application. So the lower you are in the OSI layers, the closer you are to the physical device, and the higher you are, the closer you are to the software. So OSI or Layer 1 is the physical model, is the physical layer, which represents the physical connection between devices and the sending receiving of raw data bits over a physical medium. So OSI layer 1 are things like cables, connectors, network interface cards, and modems. So these are all examples of OSI layer 1 devices. So that's the physical layer. The second layer in OSI is the data link layer. So the data link layer is going to provide reliable communication between directly connected nodes on the network. Data transmitted over the data link layer are called frames. So OSI layer 2, the data that is transmitted are called frames. And examples of things that transmit data over OSI layer 2 include Ethernet switches, wireless access points, virtual LANs, and MAC addresses. So these are OSI layer 2 devices, or devices. Anyways, the next layer is OSI layer 3. This is the network layer, which covers logical addressing, routing, creation, and forwarding of packets between devices across different networks. Data transmitted over the network layer are called packets. So in the previous layer, this information is called frames. Button layer 3, these are called packets. And things that transmit data over OSI layer 3 are firewalls, IPv4, so Internet Protocol version 4 and Internet Protocol version 6, ICMP, network address translation devices and routers. So these all live inside of OSI layer 3, the network layer. Layer 4 is the transport layer, which handles end-to-end communication, error detection and correction, and control flow in the network. Data transmitted over the transport layer are called segments. Examples of things that transmit data over OSI layer 4 are Transmission Control Protocol, otherwise known as TCP, User Datagram Protocol, otherwise known as UDP, port numbers, multiplexing, and socket programming. So this all goes over the transport layer. OSI layer 5 is the session layer, which manages communication sessions and the orderly exchange of data between devices. Data transmitted over the session layer is called data units or session data. And things that communicate over OSI layer 5 are web browsers and web servers, remote desktop protocol or RDP, and network printing. So that's layer 5. Layer 6 is the presentation layer and deals with encryption, character encoding, data compression, and format conversion. Data transmitted over the presentation layer is called data units or presentation data, and things that operate on the OSI layer 6 are media players, transport layer security or TLS protocols, file format converters, encoding libraries, and encryption/decryption software. The last OSI layer is called the application layer, and this deals with end-user applications and offers a standardized interface for diverse apps across a network. Data transmitted over the application layer is called application data or messages. And things that operate within the application layer are web browsers, HTTP, email clients, messaging apps, DNS, and database management systems, otherwise known as DBMSs. So you don't need to you don't need to be an expert about the OSI model, but you need to understand that the type of information that you're going to see inside of Wireshark is organized very similarly to the OSI model. So Wireshark and the OSI model, the Wireshark packet details pane organizes its expandable tabs according to OSI layers. Note that not all packets are going to contain layers in a sequence. This is about all the model does. Yeah. Claretto, hello, nice to see you here. Hope you're having a good time. Welcome to the stream. So for example, the first tab inside of, well, we'll talk about this in just a sec. Okay, so let's go back to TryHackMe. This is for later. Okay, so the attack box should have finished initializing. You should see a terminal like this. You want to click into it, and then you want to hit enter to dismiss the terminal message. Because we want to see our Wireshark interface as large as possible, what you want to do is you want to go over to the middle of the screen, then down to the bottom, and you're going to see this button over here. It looks like two buttons that are face away from each other. It's labeled View in Full Screen. Go ahead and click on that, and that's going to put the attack box interface into its own browser tab, which is exactly what we want. Okay, so there's actually one particular PCAP file that we want to open up using the attack box, and we can find it over here. So after the attack box desktop finishes loading, click into the terminal message, close the message, and then in the attack box desktop, click on the following folders in order: Roots Home, Rooms, AOC3, Day 9, and AOC3.pcap. So I'll just leave these in the chat. Okay, so we're gonna go back to the attack box desktop here. We're gonna click on Roots Home, and then we're gonna click on Rooms. So over here, we're going to click on AOC3. We're going to click on Day 9. WOST. Yeah, I like this one a lot. This is from the game Valhalla. It's all about cyberpunk bartending. It's a lot of fun. And if you're interested in listening to this yourself, I'll get the name that you should search up on YouTube over here. Played it and loved it. Yeah, it's a really good game. Okay, so we see here in Root, Rooms, AOC3, Day 9, there's AOC3.pcap. So you want to double click on this, and this is going to open up the pcap file inside of Wireshark. Okay, this is going to take a bit of time to open up. And okay, so the first thing I'm going to do is I think I can change this to dark mode. Otherwise, people are going to complain. I think it's view. Or is it edit? Hold on, I'm gonna look this up. Okay, Christian Ring says, crazy that people thought about and built all these layers over the last 50 years or so, but obviously they seemed to be not completely secure. Why is it not possible to build a secure system? Why is it not possible to build a secure system? I mean, I'm pretty sure when they designed the OSI model, they didn't build it with security in mind. They just built it with usability in mind. Anyways, Wireshark, dark mode. Okay, so preferences, appearance, theme. Okay, let's go back to the room. Where is... this is a bit hard to look at. Where is preferences? Preferences over here. Okay. Preferences, appearance, theme. Fonts and colors. Layout. Hold on. Let's make this a little bit smaller. The other unfortunate thing about using Wireshark on the attack box is that the resolution isn't that great. Okay, so edit. preferences, appearance. I don't see the theme. Oh, that's fine. SysOS says the layers are not built, they organically grew like that. The internet is best described as a bunch of tubes held together with duct tape and wishful thinking. I mean, that sounds about right. Anyways, we'll just keep the current theme, I suppose. Okay, so we're gonna adjust this as best we can to get the right amount of information. Okay, and then so Wireshark and the OSI model. So the Wireshark packet detail pane organizes as expandable tabs according to the OSI layers. Not all the packets will contain the layers in the sequence, but if we click on any one of these random packets, let's just say the first one, so packet number 1, we're going to see frame, Ethernet 2, Internet Protocol version 6, and then Internet Control Message Protocol. So these correspond to different OSI layers. So frame 1, this corresponds to layer 1, Ethernet 2, this corresponds to layer 2, and of course not all of the packets are going to have all of the OSI layers, but usually at least the first 2 are included in here at the top, and well, the first one and the second one. Anyways. Okay, most packets will contain data for OSI layers 1, 2, and 3. So OSI layer 1, OSI layer 2, OSI layer 3. So the second thing we're going to be taking a look at is at the display filter over here. The display filter is an important tool for managing large number of packets, which can be fine-tuned to display only packets with specific properties. The first 2 are needed to have a package. Yeah, I mean, I'm pretty sure that the first 3 are required to actually have like a packet. So if we go over to our Wireshark interface over here, so there are 3 main sections. So this is the packets list at the top here. So the packets in list form. So the packets, well, depending on the packet capture, you could have between dozens and thousands, or maybe tens of thousands of different packets that are all included in here. If you're not able to filter down into the exact packets you're looking for, you're gonna have a very bad time. So the next section that you're gonna be familiarizing yourself within Wireshark is the lower left. The lower left, this is the packet details pane. So this is all the information about the packets in detailed form. So there's a lot of information here, but the important thing is that we get rid of this text that is bothering us. Okay, so this is the packet details pane. It has all the information about the particular packet that you have selected. And the last section is the lower right portion over here. And this is the packet hexadecimal view. So this has the hexadecimal bytes that are contained in the packet. So these are the packet contents. So the reason why they're displayed in hexadecimal is because not all of the contents of these packets are going to be something that you can print. But if you use hexadecimal, you can represent the bytes in a format that is that can be printed out over here. Okay, so let's continue. So the display filter over here. So the display filter is above the list, and this lets us filter out specific types of packets. So for example, we can filter on specific protocols like HTTP, we can filter on specific IP addresses, we can filter out on all sorts of things. And it's actually something that most of us have to look up. So most of the time when I work inside of Wireshark, I'll search up something like Wireshark HTTP filter, and this will let you know what kind of filter to apply. So in this case, they want us to use specific methods. So if you wanted to get just the get methods or just the post methods, or if we wanted to get just HTTP packets, we would go back into the display filter up here and we would just type HTTP. And when you apply this filter by hitting the enter button, you're going to see that the list of packets you have here are all HTTP protocol. So you can replace HTTP with whatever protocol you want. For example, if you wanted to take a look at just FTP protocol, then we would just get the list of packets that fall under the FTP protocol. Or if you wanted to look at just DNS packets, you would type in DNS, and this just gets us just the packets that have DNS protocol information. Okay, so the amount of success you have inside of Wireshark is, I'd say it's directly proportional to how much you understand, how well you understand the packet filtering in order to not look at just a mess of packets that don't necessarily have information you want to look at. So learn how to do packet filtering, otherwise you're just going to have a bad time. Okay, so next, so that was the display filter. So we also have packet comments. So packet comments are a way for analysts to attach notes to specific packets. The keyboard shortcut for packet comments is Control Alt and C. So if for some reason there was a packet that you wanted to pay attention to, so you did, I don't know, packet 16, and you wanted to leave a comment here, you can right click on the packet, and then you can select packet comments. So you can, from here, so right click on it, packet comments, add new comment, and we could, this is packet 16. I think it is a very interesting packet. So whatever comments you want, this is basically a way of leaving little notes for yourself as you're working through the packet captures. Search also really helps. Yeah, I think we're going to talk about search in just a bit. But if you selected packet 16, you're going to see that your packet comments are included in the details pane here. So here, this is packet 16. I think it's a very interesting packet. Wow. Much wow. Anyways, so that's packet comments. So we can also filter packets by those containing comments with the display filter packet_comment. So if we go back into the filter up at the top and then type out packet_comment, this will only return the packets that have comments attached to them. So let's go ahead and do that. So we're going to go into display filter PKT_comment. Okay, and there's only one because we only put a comment on one of these. SysOS says this packet is very, yeah, let's investigate, of course. All right, let's go back. So packet comments, I think what we need to do now is we need to follow the room. So the room is going to ask us to get information about specific packets. So we're going to go back to here, Advent of Cyber 3, and we're going to go back to task number 14. Where is all this data going? So there's a lot of information here that talks all about packet analysis. It talks about packet analysis tools, Wireshark. If you're very interested in learning more about Wireshark, definitely come back and read all the information that is attached here. But for our purposes, what we want to do is we just want to answer the questions at the end of the task to practice using Wireshark. Okay. Alright, so answer the following questions below. But you know what? I've answered these questions already. I'm just going to reset the answers so that it's a little bit harder for us. Okay, so options, reset progress. Okay, Victor86, is TryHackMe free? There's free parts of TryHackMe and there's paid parts of TryHackMe. The stuff that we're dealing with today is all free stuff. And I very rarely cover like paid content because I believe that I should provide free education alternatives to the people in the community. But anyways, let's go back to task number 14, and we'll go down to the questions. Okay, so answer the questions below. In the HTTP1 GET request section, what directory is found on the web server? Okay, so in this case, we're applying a very specific type of filter. So it's http.request.method equals get. So the filters look kind of programmatic, and I'm pretty sure that's very intentional. So we'll go back into our machine, and we'll type http. What was it again? HTTP request method. http.request.method equals get. So what this is going to do is it's going to filter on only packets that include an HTTP request that uses the get method. So in this case, there's still quite a few. There's still quite a few of these packets. I'm going to say that there's like 20 or 30 of these packets, but I think we've got enough here to answer the question. And the question is, which directory is found on the web server? So if we go over to our list view, and we can start messing around with the columns over here to get maximum information. So what we see here inside the info is that they're the actual endpoints that are being accessed. So there's the login endpoint, there's the www endpoint, the cPanel endpoint, and I think what they're looking for is the login endpoint over here. So when I talk about an endpoint, we're just talking about like a web page or a directory. So in here, the first question, the answer is the login endpoint. So just type in login, check. Okay, and they actually have a picture here that illustrates what we're supposed to be looking for. Okay, so the next question is, what is the username and password used in the login page in the HTTP2 post section? So in this case, we're looking at a different type. I thought it was an admin. Where did you think you were an admin? Okay, so in here, what is the username and password used in the login page in the HTTP post section? In this case, we're looking at a different filter, and in this case, it's the post method and not the get method. Remember that get is used to get the contents of web pages, and post is used to send information to the web page. So we're going to go back in. We're going to replace the request method from get to post and filter on this. And we'll see here, there's actually some information in the hexadecimal view. So another thing what we can do is we can actually take a look at the information that was sent in the exchange by right-clicking on this packet and then choosing the follow option. We can follow the HTTP stream, and this is going to be information about this is going to be the information that was exchanged between the server and the browser, I guess. And in this case, we see here that the information that was being sent includes this. So username equals McSkitty and password equals Christmas 2021 and %21. %21, I'm pretty sure this is like the exclamation point. This has been URL encoded. So this is not literally %21. Okay, so the answer here is McSkitty colon, what was it again? Christmas 2021. Okay. Let's just copy that. So we'll copy it, we'll go back. We'll paste this over here. Christmas 2021, And if we go over to our URL encoding, just to double check, URL encoding %21, and it'll probably tell us what the actual character is. Oh, it doesn't tell us? Okay. Okay, maybe we'll find out here. So %21 is the exclamation point. So if you see %20, that's a space. %21 is the exclamation point. Thank you very much for subscribing on YouTube, Duck. Much appreciated, thank you. Okay, so we'll go back to the TryHackMe page. McSkitty, Christmas 2021. Submit that, and we're done. Okay, what is the user agent's name that has been sent in the post section? User agent's name. HTTP #2 post section. Alright, so I think what we need to do here is we need to take a look at the post requests, and we need to pay attention to the user agent. So we'll go back here. We'll do our filter, http.request method equals post. And then we'll pay attention to the user agent. So the user agent is down over here. User agent TryHackMe something something. It looks like a flag down here. But we can also see this in the packet details view. So if we go into the HTTP form URL encoded, actually no, we want to look at the hypertext transfer protocol. So click on this. So all the headers that are sent in this particular HTTP request are over here. So the host, the user agent, accept language, all of these HTTP headers. What you want to do is you want to highlight the user agent, right click, and then select copy value, because we want the value of the user agent header. Okay, so click on that. I think, yeah. So this is our flag over here. Paste it in here, click on check. We're done, go okay. So it says in the DNS section, there's a txt DNS query. What is the flag in the message of that DNS query? So we're looking at a different protocol now. So we're looking for DNS packets. If we go back and we change up our filter to only look for DNS, so type in DNS and then apply the filter. We're looking for, I think we're looking for txt. So the info over here, I'm pretty sure we can find this stuff in the domain name. We can look through these. We can also search. We can also search for txt specifically. So over here, they're talking about a txt DNS query. And if we go into Wireshark and then we open up the search. So we can open up search with the Control F keyboard shortcut. So Control F, that's going to open up the display filter over here. So we can search for specific words. So enter a display filter, type in the word txt, and apply as a string. So display filter, hex value string. So we're looking for the exact string txt. Okay, and then click on find. And we see here that there's a txt packet, packet.tryhackme.com. Okay, I think this is the answer we're looking for. We go back. What is the flag in the message of that DNS query? What is the flag in that message? Well, I guess they were looking for us to follow the stream. Okay, so this is how we do it. We're going to go back. We're going to right click, and then we're going to follow the UDP stream. Okay, and it says And we're looking for this flag value here. So THM, this thing. Okay, copy that. I wonder if you can find this in the data. Just a second. Okay, so let's see. So if we go up here, we have our flags. No, doesn't look like we're looking for these. We have our queries, we have our answers. So we can't really see it in... We don't really see it in the detail pane, but we do see it in the hex view over here. Interesting. Okay, so we'll go back and we'll submit this flag. And then we'll move on to the next thing. So in the FTP section, what is the FTP login password? So FTP login password, we're talking about a different protocol now. So the FTP protocol, which is used to transfer files. We'll go back and then we'll get rid of our previous filters, and we're going to filter on only FTP now. So type in FTP, hit enter. And now we've got all these FTP packets. So generally when you're dealing with FTP, you can see what you want to do is you want to take a look at the conversation that's traded between the server and the browser. So we can click on the first FTP packet, right click, and then follow TCP stream. So this is going to be the communication between the server and the browser. So server sends this, client sends user TryHackMe FTP, TryHack FTP. And then the server asks for the password, and then this password was sent over. So what are they looking for? They're looking for the command or the password. What is the FTP login password? So they're looking for the password specifically. We can select this from the conversation, copy, go back, paste this, submit. Okay. So in the FTP section, what is the FTP command used to upload the secret.txt file? The secret.txt file. So this actually requires us to understand the different FTP commands. So if you go back, so the whole conversation is here. So these are all the commands that are being sent. So user is used to specify your username, pass is used to specify your password. So CWD files. Oh, CWD, huh. Okay, so this one is used to change directories, so into the files directory. And then the last command over here is being used to upload a specific file. So the command is actually called STOR for store. This uploads a file to the FTP server. So store secret.txt. I'm just going to copy this and submit this. To submit this as the answer. Oh, they don't want the file name. They just want STOR. Okay. Turns out we didn't need to actually look it up because the answer is in the screenshot over here. All right, so in the FTP section, what is the content? What is the content of the secret.txt file? So the content of the secret.txt file, we can look this up as well. So if we go down, this is packet. So it tells us which packet is associated with what we're looking at. In this case, store secret.txt is associated with packet 1087. And I'm pretty sure we can navigate directly to 1087 over here. Okay? And when we do that, Store secret.txt. The other way we could actually look at the contents of secret.txt is we can use another feature of Wireshark. So another really important feature of Wireshark is the ability to extract files from the packet capture. So if we go over to File, up to File, and then select Export Objects, and then select the protocol that is being used to send those files. So in this case, it's FTP data. So export file, export objects, FTP data. And we see here that there's one file called secret.txt. So we can save this file as to our current machine. So click on it and then select Save. So select the file, click on Save, and then we have to select somewhere to save it to. I think this is going to save it to, let's save it to the desktop. Okay, and then click Save. So after we've done that, we're going to minimize Wireshark, and then we see that secret.txt has been saved to our desktop. And click on that, and then we see AOC flag 123. Are they looking for this entire thing? So we'll copy that, we'll go back to TryHackMe, and we'll paste in, okay, they don't want AOC flag, they just want this portion. So this thing here, we'll copy that, paste this in, click check, and that's it. Huh, wait, it says that there are two things that we missed. Where did we miss anything? It might have been up at the top. Nope. Okay. This task is done. Okay. All right. So there's if you have any questions about any of the stuff that we're doing inside of Wireshark, let me know and I'll try to answer the questions as best we can. Wireshark is a very, very deep program, and understanding everything it's hard to know everything from Wireshark. If you want to learn more about Wireshark, we're going to be doing, the next class we're going to be doing is where we're going to be taking a look at more Wireshark stuff. Anyways, we've got birds to put on because there's a break happening, an ad break happening on Twitch right now. So let me put on these birds. Okay, we'll be back in about 60 seconds, but enjoy these birds arguing with each other. We'll be back in about 60 seconds. Okay, we've got about 10 minutes left in the session. I think I can point you towards more education resources if you want to learn about Wireshark and packet capture stuff. Let's put the birds away, and then so if you want to learn more about Wireshark and packet capture, I'd say that a good resource is this one from Hack the Box. So hackthebox.com, academy.hackthebox.com. Let me log in. Where's the login? Just a second, everybody. Sign in. Okay, they've got a sign in page here. I didn't see it. Okay, where's that sign in? I just wanna sign in. We are so back, are we? Okay. Sometimes the TryHackMe app is a bit frustrating to deal with. Just a second. Okay, am I... No, that's TryHackMe. I want to do Hack the Box. I watched your last stream. I like that there's a cybersec-oriented stream. Cybersec-oriented stream. Yeah, I mean, if you're looking for more cybersecurity-oriented streams, there's a big community of us over at infosecstreams.com. So this shows when different people in the infosec community are live streaming on either Twitch or YouTube. So you can see the people with the little green dot are the people who are live. Okay, verify I'm human. Okay, so let's take a look at our academy. Why am I not logged in? Okay, we should be logged in here. Okay, so in Hack the Box Academy, there are a bunch of free modules. They're not exactly free, but there are a limit to how many you can have going on at once. But let me point you towards a module that you might want to take a look at if you want to learn more about packet capture and Wireshark and stuff. So we're looking for Intro to Network Traffic Analysis. So I highly recommend this if you're looking to learn more about Wireshark. And the other thing that I can point you towards is AllaCyber. So training.allacyber.it. So AllaCyber is an Italian cybersecurity education platform, but they've got very, very good education resources in the form of their challenges over here. If you take a look at the challenges on the website after you've logged in, and of course everything's in Italian, but on most of your modern web browsers, there should be a translation plugin. So if you click on the options here, you can translate the page from Italian to English, or whatever language that you're most comfortable learning in. And the network security challenges in the introduction series over here, they're very, very good for introducing one concept at a time while solving challenges. So this is what I recommend. Will you stream at this time tomorrow? No, I stream twice a week. I stream on Wednesdays and Fridays, and you can usually find the schedule for the stream over at the Reddit for HackerFrogs. So this is this week's schedule. But let's go ahead and wrap up today's lesson. So we talked about network traffic. Anytime a network device sends data from one device to another, network traffic is generated as network packets are being sent back and forth. We also talked about PCAP files, files which contain a collection of network traffic. A collection of network traffic are called packet capture or PCAP files, and one specialty of digital forensics is the analysis of network traffic in PCAP files. Wireshark is a program which is widely used for network traffic analysis, and we'll learn to use it to analyze PCAP files. So in the next digital forensics workshop, we'll practice more with network traffic analysis with the TryHackMe platform. So what are we going to be talking about next stream? Let me just take a look at the session notes. So more network traffic analysis. Okay. So we're going to be doing some more complicated application of Wireshark, also using TryHackMe. Let me just double check to see if this room is still free. Sometimes TryHackMe changes rooms from being free to being paid, which is a bit of a pain in the butt. But this room is still, it looks like it's still free. So if somebody could double check for me and tell me if this room is free for them, please let me know. But I guess with that said and done, we can move on to the next part of today's stream, which is topic number 4. So if we finish topic number 4 early, we might move on to some bonus challenges. But we're going to be doing this challenge from TryHackMe, and we're going to be covering a very recent vulnerability that was discovered in Linux. It's called copyfail. Okay, I can open the room and it's not labeled premium, should be free. Thank you very much for confirming for that for me, SysOS Master. Sometimes free for one user isn't free for another user, which can be very, very confusing. Okay, so 60 minutes for this topic. So what we're going to do is we're going to cover this TryHackMe room. It talks about copyfail. It's it's Yumiko. Thank you very much for letting me know about that, and welcome to the stream. So this is a very recently discovered vulnerability. It was discovered less than 2 weeks ago, and we're just going to talk about what exactly this vulnerability is. So we're just going to join the room, and then we're going to interact with the virtual environment. So to successfully complete the room, you're going to need to set up your virtual environment. This involves starting the target machine, ensuring that you are equipped with the necessary tools to access and tackle the challenges ahead. Okay, so we're just going to, under task number 1, we're going to start the machine here. And okay, so this is another virtual machine that we need to access. So good thing is that we don't need to use the attack box. But while we're waiting for this to load up, we can read all about the vulnerability. So it says, most local privilege escalation exploits are fragile. They depend on precise kernel version offsets, requiring winning a race condition reliably, or crash the system when timing slips. CVE 2026, this number, nicknamed copyfail, is none of these things. A 732-byte Python script with no external packages, run by any unprivileged local user, returns a root shell in seconds. So this means that with this vulnerability, any unprivileged user, so any low-level user, can become the root user or the super user, which is a very bad thing for security. Okay, so the researcher's own description of the primitive frames, concisely. An unprivileged local user can write 4 controlled bytes into the page cache of any readable file on a Linux system and use that to gain root. An unprivileged local user can write 4 controlled bytes into the page cache of any readable file on a Linux system and use that to gain root. Okay, so let's read more. So copyfail was assigned this CVE number over here and a CVSS v3.1 base score of 7.8 high. So CVSS is a numerical system used to rate how serious vulnerabilities are, with from 0 to 10, and all of the most serious vulnerabilities are given really high numbers like 7, 8, 9, and 10. In this case, it's pretty close to 8, which means it's a very serious vulnerability. So it was reported by Taeyang Lee, a researcher at Theory, who paired his own domain insight into the Linux crypto subsystem with Zint xint code, an AI-assisted code analysis tool developed at Theory. So an interesting thing about this particular vulnerability is that AI tools assisted in discovering it to scan the kernel's crypto code paths and surface the bug. The full disclosure is published on the xint research blog. The Linux kernel security team was notified on the 23rd of March, with public disclosure following on the 29th of April. So yeah, so this is from the beginning of this month. So it's been about 2 weeks since it's been publicly disclosed. The vulnerability sat silently in virtually every mainstream Linux distribution for 9 years, from a 2017 kernel optimization through to the April 2026 patch. Okay, it's Slizzo. Hello, nice to see you here, and hope you're having a good Wednesday. If you're familiar with CVE 2022 Dirty Pipe, the class of primitive that drives copy fail will already be familiar. Both exploits write into the in-memory page cache of a file without touching the on-disk content, and both bypass file integrity monitoring as a result. The underlying mechanisms differ. Dirty Pipe used a flaw in the pipe subsystem, whereas copy fail abuses the kernel's AFALG crypto socket combined with the specific AEAD template. Despite the different entry points, both fall into the same attack surface of kernel-level page cache writes via the splice function. The two are compared below. Okay, glad you're around. Well, thank you. And Supreme Overlord, hello, nice to see you here. Hope you're having a good day. Okay, so what are we looking at? So kernel subsystem, Dirty Pipe uses pipe and splice, while copyfail uses AFAlgo crypto splice. The write primitive used in Dirty Pipe is arbitrary via pipe flag bugs, and in copyfail it's controllable 4-byte via authentication scratch. Okay, race condition required. So yes in the case of Dirty Pipe, Dirty Pipe, but no in the case of copyfail. Kernel offsets needed, no. On file disk changed, no. File integrity bypass, yes in both cases. That's the function name. O for the work, okay. Alright, so the no in the race condition row is what makes copyfail substantially more reliable as a weapon. A race-based exploit may fail a fifth of the time, demand a retry loop, or hang the system on a bad attempt. The copy-fail write is deterministic. It either lands cleanly, or it errors without side effects. That reliability drove the rapid weaponization observed after disclosure, with multiple public reimplementations appearing within 24 hours. Okay, so this was a big bad bug, which works reliably, which means that it was used by bad people. Okay, so our learning objectives today. By the end of this room, you will be able to explain the page cache write primitive that makes copyfail exploitable and why it bypasses file integrity monitoring. Identify the 4 kernel components: the page cache, the AFALG, the authenticin, and the splice that combines to create the vulnerability. Execute the proof of concept as an unprivileged user and obtain a root shell. Describe the primary detection signals and apply the mod probe mitigation on Ubuntu and Debian systems. Prerequisites. This room assumes comfort with the Linux command line, including basic shell navigation and reading command output. As covered in Linux fundamentals, it also assumes a working understanding of local privilege escalation concepts as introduced in Linux privilege escalation. Okay, so this is a local Linux privileged escalation exploit that we're going to be taking advantage of here. Connecting to the machine. Click on Start Machine. Okay, we did that. And we're working as the Karen user. So everything's A-okay. So we can clear the screen. We are Karen, and this is the copy fail machine. Okay, all that is good. And we'll move on into task 2, the vulnerability. Okay, copy fail emerges from the interaction of 4 independent components of the Linux kernel, each of which behaves correctly in isolation. The vulnerability does not exist in any single component. It lies in what happens when they meet, specifically when a 2017 optimization intended to make one of them faster failed to account for a data path that was not considered at the time. ID. So we are UUID 2001. We're not part of any special groups. Okay, in this section we cover each component in the order it appears in the exploit, before describing how the combined behavior produces the right primitive. So the first thing we need to learn about is the Linux page cache. The page cache is a region of kernel memory that holds copies of recently read file contents to avoid repeated disk reads. When any process reads a file on Linux, the kernel reads it from disk once into the page cache, and every subsequent read of that file by any process is served from the cached copy. Okay? The cache is shared. All processes on the same system, including every container sharing the host kernel, see the same cached pages for a given file. Writes to a file ordinarily update both the on-disk copy and the cached copy. MSEC, hello, nice to see you here. We're learning about copy fail over at TryHackMe right now. This is the link over here if you want to try it out yourself, but welcome to the stream. Did you know that MSEC also streams? Let me give him a shout out. So if you're on Twitch and you want to check out MSEC stream, please click on the link. Okay, so what are we talking about? Okay, writes to a file ordinarily update both the on-disk copy and the cache copy. However, the cache copy can also be modified directly without any change being written back to disk. Okay? So a useful analogy is a photocopier with an internal print buffer. The original document remains on the glass, but every print job is reproduced from the buffer rather from the glass. If the buffer contents are tampered with, every printout is wrong. Inspecting the original document on the glass shows nothing out of place. Okay, so this matters because file integrity tools such as AAD, Tripwire, and IMA work by hashing the on-disk file. They read from disk, not from memory. If the page cache has been corrupted, but the disk is untouched, every integrity check passes. The hash check reports the file is clean, while the binary the kernel actually loads when the file is executed is the corrupted in-memory version. Okay, so let's put this in a new tab. Okay, copy fail where the 4-byte write lands. The page cache is corrupted in memory. The on-disk file is never touched. So let's see. So the page cache is the kernel memory over here, and it's being used by process A, process B, and process C. So the file on disk is not changed, but it's changed inside of the page cache. And then 4 bytes are written via the AFALG and the Authoscan by an unprivileged local user. And that's where the bad stuff happens. Okay, let's go back. So AFALG, the kernel crypto socket. AFLG, Address Family Algorithm Socket Family number 38, is a Linux socket interface that exposes the kernel's cryptographic subsystem to user space. Introduced in kernel 2.6.38, it allows users to repeat AEAD encryption and decryption, hashing, and symmetric cipher operations through standard socket calls such as bind, send message, and receive message. The property that matters for this exploit is access. AFLG is available to unprivileged users by default. No cap sysadmin or any other special capability is required to open such a socket. Legitimate software that uses AFLG is a short and well-defined set, including crypt setup, systemd crypt setup, kcapi encode, kcapi encode, kcapi digest, kcapi mac, and kcapi speed, and the charon and charon systemd daemons used by Strong Swan for IPsec. This list becomes the baseline for detecting anomalous AFLG usage in Task 4. Okay, so we've also got AuthentiScan and the scratch write. So AuthentiScan is a Linux kernel AEAD template used for IPsec with extended sequence number support, ESN. During an AEAD decryption operation, AuthentiScan writes 4 bytes, the lower 32 bits of the extended sequence number stored as sequence number low at the offset ASOC len and crypt len within the output buffer. This write is a scratch operation the algorithm performs to rearrange the sequence number fields before verifying the authentication tag. The detail that makes this exploitable is the order of operations. The scratch write happens before HMAC tag verification. The algorithm writes its 4 bytes into the output buffer first, then checks whether the HMAC tag is valid. If the HMAC check fails, and in this exploit it is deliberately made to fail, the error is returned to user space. However, the write is already landed. There is no rollback, no cleanup of the output buffer, and no mechanism to undo a write that is already completed. A common confusion point is whether the failing HMAC verification implies that the operation as a whole was rolled back. It does not. The write happened first. The failure only means that the authentication check at the end of the operation rejected the data. The 4 bytes written as scratch value during processing are already in the output buffer by the time the HMAC result is evaluated. Both the value and the destination of the write are attacker controlled. The attacker controls the value through sequence number low, which is derived from fields in the message they construct. The attacker controls the offset within the output buffer through ASOC len and crypt len. This gives full control over both what is written and where. Splice and page references. Splice is a Linux system call that moves data between 2 file descriptors by transferring page references rather than copying the data. Transferring page references. So page references refers to the in-memory version of the data. When you splice from the regular file into a socket, the kernel does not copy the file contents. It hands the socket a reference to the same memory pages already used by the file's page cache. This zero-copy behavior is what makes splice fast. It is also what makes it dangerous in this context. After a splice from user bin su into an AFLG socket, the AFLG pipeline holds a reference to the live page cache pages backing user bin su. Those pages are kernel-owned page cache pages, not a user-controlled copy. The 2017 optimization. Before 2017, ALG if AEAD, the AED implementation in the AFLG subsystem, maintained separate source and destination scatter lists for cryptographic operations. A scatter list is a linked list of memory pages describing where input data comes from and where output should be written. So this commit in kernel 14.4.14, is there an error? Is there an error? YouTube is not... Okay, it looks like I'm experiencing some sort of technical difficulties on the YouTube side. People who are watching on YouTube, let me know how the video performance is right now. Although you probably wouldn't be able to tell if the video performance was really bad, because I'm not really moving too much on the screen. Okay, let's see. This introduced an in-place optimization. Instead of keeping separate source and destination scatter lists, the code merged them and set rec source equals rec destination. Required source equals required destination. For the common case, whether the user supplies data via the normal write, this was safe. Both the sides of the assignment referenced user-controlled memory. The optimization was written without considering the splice data path. When data arrives via splice from a file, those pages are not user-controlled memory. They are the kernel's own live cache pages for that file. Oh, is your browser okay? Setting required source equals required destination to the same scatter list means that the output scatter list now points directly to the file's page cache pages. The authentiscan scratch write targeting the output buffer was now writing into the kernel's page cache. The resulting primitive, combining all four components. I see no issues with the YouTube feed. Huh. I'm getting some sort of error message on my side in YouTube, but if you don't see any errors on your end, then maybe it's okay. Combining all four components produces a controlled 4-byte write to an arbitrary offset within the page cache of any file the attacker can open for reading. The attacker controls the written value through the sequence number low and controls the offset through the splice position combined with the ASOC length and crypt length. The HMAC verification fails afterwards, returning an error to user space, but the write is already completed. Yeah, YouTube's a very... YouTube can be a very quirky app sometimes. Okay, the exploit repeats the primitive approximately 40 times to write successive 4-byte chunks of shellcode into the target file's cache pages. Each iteration opens a fresh AFALG socket, splices the target file at the next offset, and calls the receive message call to trigger the scratch write. Each call corrupts exactly 4 bytes of the page cache. After roughly 40 calls, enough shellcode is in place to overwrite the target binary's execution path. There is no race condition, no kernel version specific offset table, and no external tool dependency. The same script runs on every vulnerable kernel, which spans 4.14, which was released in November 2017, through 6.18, 6.18.21 in the 6.18 series, and 6.19.0 through 6.19.11 and the 6.19 series, covering 9 years of Linux distributions. Hey, Sick in the Mind, what is up? THM made a copy fail box? Yeah, they did. They also made a dirty frag box. So I'm going to be covering copy fail today, and I'm going to be covering dirty frag on Friday. Okay, so what year was the optimization that introduced that created this vulnerability? This was 2017. Okay, and which AEAD algorithm template performs the scratch write that corrupts the page cache? It's a pretty good copy fail explanation. I mean, I'm not I'm not a Linux expert. I'm trying to keep up as best as I can. Which AEAD algorithm template performs the scratch write that corrupts the page cache? So let's... Was it splice? Oh no, it's AuthenticScan. I mean, I'm not too sure how to pronounce this thing. You are. I mean, that's good. That's good that we've got someone here that can explain this stuff. So anyways, this thing. Okay. What system call transfers page caches into the AFALG socket without copying them? Which system call transfers page caches? I think it was splice. Okay. And the HMAC verification fails after the scratch write is performed. Does this undo the page cache corruption? Answer format yay or nay. The HMAC verification fails after the scratch write is performed. This does not undo. So this is where the problem lies. So this nay. Okay, Sysmaster says, I went through it. Cannot explain it any better than THM is doing here. I mean, here's a good use of the AI. If there's any part of this explanation that you don't quite understand, you could copy this into our good friend the AI to have it try to explain in a different context, maybe, to help you understand what the heck is going on here. Okay, so let's see, exploitation. So the proof of concept script pre-placed on the machine targets user bin su. It overwrites the cache copy of that binary with shellcode, after which any execution of su runs the shellcode with setuid root privileges. The complete operation takes a few seconds. The exploit used in this task is hosted at GitHub, so if you're interested in taking a look at the original exploit file, it is over here. Okay, when the start machine button is pressed, the room opens a split view terminal in the browser. Okay, so we've already done this stuff. Okay, confirm the current user has no elevated privileges, so we don't have any elevated privileges. We are... Well, we don't have the password for Karen. Whoop. One incorrect password attempt. Are we being logged? Okay, this is a starting context that the exploit requires. No elevated privileges, no special groups, just an ordinary local user. Inspect the proof of concept. The exploit script lives at exploit.py. Okay, well. So import OS, and then we've got the OS module that is being used, and we also have the zlib module and the socket module. Okay, the script uses only Python standard library modules. The OS module supplies splice and exec VE, and socket provides the AFALG socket calls, and zlib is used for CRC calculations when building the authentication key blob. There are no pip packages and no compiled extensions. The script runs on any Python 3.10 or later installation. Ubuntu 24.4 ships Python 3.12, so os.splice is available out of the box. At a high level, the script performs the following steps in sequence. Opens an AFALG socket bound to AuthenticScan, HMAC, SHA-256, CBC AES, calculates the target offset within user bin su, where each shellcode chunk should land, constructs the AAD, so the bytes 4 to 7 carry the shellcode value to be written as sequence number low, calls splice to feed page cache pages from user bin su, into the socket at the calculated offset, calls receive message to trigger the AEAD decryption, at which point AuthentiScan performs its scratch write and the shellcode bytes land in the page cache. Repeats approximately 40 times to write successive 4-byte shellcode chunks, calls os.execve user bin su so that the kernel loads from the corrupted cache and the shellcode runs. Okay, so I wonder what the shellcode looks like inside of here. Okay, let's take a look at the illustration. Okay, copy fail exploit flow. Unprivileged user, local user to root in approximately 40 system calls. Okay, so 1, socket, AFALG socket sequence packet, open AEAD socket bound to AuthentiScan, splice, user bin su, alg fd, feed page caches into the crypto pipeline, receive message, times 40, each call writes 4 bytes of shellcode into the cache. HMAC verification fails. Error returns, but the 4-byte writes have already landed. Execute VE user bin su. Kernel runs the corrupted cached binary as UID 0. So runs the binary as UID 0. UID 0 is of course root, and it runs the shellcode that we wrote into the page cache of user bin su. And assuming that this is shellcode, it opens up a root shell for us. And then root shell UID equals 0, set UID binary executed against corrupt page cache. No race condition, no kernel offsets. Same script works on every vulnerable kernel between 4.14 and 6.19.11. So this is pretty bad. Okay. So step 3, run the proof of concept, execute the script. So just run Python with the script. The script prints the progress as it writes each 4-byte chunk. After the write's complete, it calls execute CVE on the target binary. The shell prompt should change and the effective user ID becomes root. Okay, it's worse, it pollutes SU, so any call to SU will yield a root shell. I mean, I'm assuming that we can replace user bin su with any other root-owned binary, or does it need to be specific binaries on the system? Okay, so Python exploit.py. I think we need to run Python 3 specifically, and we're root. Yay! Wasn't the script supposed to give us progress? I guess not. You need to craft the payload to the bin, but yes, once you root though, why care? I guess so. I guess if you're a hacker man, you don't care about the system after. Well, I mean, I'd probably want to use a binary that's not used very often, so that even if it is corrupted, that it's a little bit more hidden. I mean, I'm not completely sure. Anyways, okay, read the flag. There's a flag in root.txt. There's a flag.txt file in root. So well, let's just wander on into root then. Okay, we got flag.txt. Let's read it. SU is not often used for non-root use. No, that's true. Okay, let's change up our music. Let's do some space music. Okay, cat flag.txt, copy fail, kernel LPE. But thank you very much for subscribing on YouTube at NorCal CBR. Thank you. Okay, let's copy that. Actually, let's just copy this. Okay, so step 5. Step 5 The SHA-256 sum moment. While still in the root shell, verify the file just exploited against its expected on-disk hash. Okay. Hold on. Let me see if I can store my flag somewhere. Okay. And then run SHA-256 sum on user bin su. Sure. Can't clear the screen. Okay. SHA-256 sum. User bin su. So this is the hash here. Okay. That hash matches a freshly installed unmodified system. ADE, Tripwire, and IMA would all report this file as unmodified. A file integrity scan run at this moment returns clean. The exploit only modified the in-memory page cache copy. The on-disk binary at user bin su was never written to. File integrity tools read from disk, compute the hash from disk, and compare against a baseline taken from disk. None of that touches the page cache. The corruption used to gain root is invisible to every file system-based integrity check. This is a core property of the vulnerability rather than an incidental side effect. Any detection strategy that relies on watching for changes to set UID binaries will miss this exploit entirely. Oh. Okay. So the other requirement for this particular exploit is that it has to target a set UID binary. So let me check what the set UID binaries are on the system. So here would run like find. So it's not every binary that you can target with this vulnerability. It has to be a set UID one. But on any Linux system, there are going to be a bunch of set UID binaries. So any of these binaries are going to be a suitable target. So like G, umount, su, sudo, chfn, any of these things over here. Okay. So copyfail is not the first exploit to bypass file integrity monitoring this way. Dirty Pipe had the same property. The page cache is an attack surface for file integrity bypass is a recurring theme that predates both CVEs. What distinguishes copyfail is its reliability. There's the absence of a race condition means that the attacker can run it once and expect it to work. Exit the root shell. Okay? So when the root shell was spawned, execution passed through the corrupted page cache. As part of cleanup, the POC calls POSIX fadvise, POSIX fadv don't need on user bin su. This hints to the kernel that those pages are no longer needed, and the kernel evicts them from the page cache. The next time any process reads user bin su, the kernel reloads the original clean binary from the disk. So this is... Okay, so I thought that using this exploit would corrupt the binary that was being targeted, but it turns out that's not the case. So after you exit from your root shell, then the user bin su binary, whenever the binary is next used, it should be the clean version. So I guess it's not really detectable. For Defender, this means that the exploitation window is extremely narrow. The corrupted pages exist in memory only between the last receive message call and the POSIX fadv don't need cleanup. So it corrupts the copy of the binary in the page cache. Yeah. And a window measured in seconds. By the time a file system-based alert fires and the responder opens a terminal, the page cache already shows the original binary. There is nothing to find on disk and nothing in the current page cache. Detection must come from observing the exploitation as it happens, which is covered in Task 4. Okay, note rerunning the POC in Task 4 to verify the mitigation blocks. To verify the mitigation blocks, it is supported. What? The cleanup step evicts the corrupted pages, so the next execution of user bin su loads cleanly from disk. What is the content of flag.txt? So I copied it. Just a second. Okay, so detection and remediation. So the exploitation window for copy fail is seconds wide. The on-disk file is never modified. The page cache is clean by the time cleanup runs, and the POC only uses standard library calls that blend in with normal process activity. File system monitoring, file integrity checks, and binary signature validation all miss this entirely. What remains detectable is the process behavior, specifically the sequence of system calls that no legitimate application produces at the volumes the exploit requires. Detection. AFALG socket creation, the primary signal. The exploit must call socket AFALG socket sequence packet 0, okay, approximately 40 times in rapid succession, once for each 4-byte write chunk. Each call opens a fresh AFALG socket, and 40 shellcode bytes require roughly 40 iterations. The socket sequence packet detail matters for detection precision. AFALG sockets opened with SOCDgram are commonly used by hashing and symmetric crypto operations, which produces background noise on busy systems. Socket sequence packet is the type used for AEAD operations and is far less commonly seen on a healthy system, making it a higher fidelity filter for this exploit chain. The list of legitimate processes that open AFALG AEAD sockets is short and well known. It includes crypt setup, systemd crypt setup, KCAPI encode, KPAPI digest, KCAPI Mac, KCAPI speed, blues, IWD, and the charon and charon systemd daemons used by strong swans for IPsec. Any process outside that list creating an AFALG socket sequence packet socket is unusual. A process outside that list creating 40 or more such sockets in a few seconds is almost certainly running this exploit or a derivative of it. The socket AFALG something something call uses domain value 38. In audit D, this translates to -f AO equals 38. The rule below fires on the very first socket call before any page cache corruption has occurred. Okay, so this is detection. Key syscalls to monitor. System call is socket AFALG. Watch for any process outside expected allow list. This is the primary signal that fires before corruption. I'm going to give myself a little water break. Just a second. Okay, the next one is splice. Splice from a set UID binary FD into a socket FD. Okay, page cache pages entering the crypto pipeline. So watch out for the splice system call and watch out for the receive message on AFALG FD. 40 calls, approximately 40 calls in seconds from the same PID. Each call writes 4 bytes of shellcode. And we've got POSIX F advise don't need, called in a set UID binary shortly after AFALG activity. This is the indicator of attacker cleanup and page eviction. So this is the cleanup of the exploit after it's done. Okay, Falco rule outline. What is Falco? For environments running Falco or compatible eBPF monitoring tools, the detection logic resembles the rule below. A live Falco installation is not required to follow the example. The rule is included as a reference for how detection logic is encoded. So this is... Oh, okay. So this is... These are monitoring tools. And these are the rules that you would feed to your monitoring tools to ensure that it would be able to detect this kind of activity. Okay. The rule fires on the first socket call from any process not in the allow list. So they're looking for kernel socket calls to any process that is not in the correct list of processes. At this time, no page cache corruption has occurred yet, so an IDS or SIM that correlates repeated AFALG alerts from the same PID with the subsequent exec VE of a setuid binary in the same short window has a high confidence exploit chain indicator. Detection timing. Okay, so I think the rest of this is going over detection of this particular vulnerability, and the last thing we're looking at is this patching or finding ways to exclude the vulnerability. So the vulnerability lives in the alg-if AAD kernel module. Disabling that module removes the exploit's ability to open an AF-ALG socket bound to the authentiscan. Mitigation, not patching. The permanent fix is a kernel update. So you can do an update on your operating system to permanently protect your system from this particular exploit, or vendor backport of the same fix with a mainline patch landing as commit this thing over here on the 1st of April 2026. Until your distribution ships a patch kernel, the mod probe blacklist is the recommended interim mitigation on Ubuntu and Debian systems. Verify the module is loadable. First confirm that the alg-if AEAD is a loadable module on the system rather than being compiled directly in the module. Okay, do they want us to run this command here? Mod info alg-if AEAD. Okay. Module information should be returned, including the file name path. If the command returns module information, the mod probe blacklist approach will work. Step 2. Apply the mod probe blacklist. Okay, so I guess we're patching our system in real time. I don't think we can do this. We can't do this because we need to run sudo. Yeah, you would need root. Actually, we've got a method of becoming root right now, so maybe we can patch this. Machine, yeah, 15 minutes should be enough. Python 3 exploit.py. Okay, now we're root, so we can actually apply the patch right now. We just need to modify this so that it's not running sudo because we're already root. Just a second, let me modify this. We don't need to sudo entity because we're running as root. Okay. Sudo, it does work for root, but it's kind of redundant because we are. Do we not get to paste here? Oh no, we do get to paste. Okay, that's good. Okay, so then we sudo rmmod or true. I mean, I'm pretty sure. Just run this thing. Okay, so the first command writes a configuration file telling mod probed to run bin false instead of actually loading alg-if AEAD. The second unloads the module if it is currently in memory. The or true on the rmmod line prevents a harmless error from stopping the command. if the module is already unloaded. Verify the block is active. So this command should return an error. The module load is blocked. Okay, so we'll run mod probe alg if aed. Okay, we got the error, which means that this should be patched. Confirm the POC fails. Rerun the exploit script. Okay, so we'll just need to exit out of here, and we'll try to rerun this command. Okay, so it doesn't work. It doesn't work, which means we've patched the system against the exploit. The script should now fail at the very first step. The socket AFALG calls an error, returns an error because the module cannot be loaded, and the rest of the exploit chain never executes. This is the expected outcome once the mitigation is applied. The mod probe blacklist only works on distributions where ALG if AAD is a loadable kernel module. On Red Hat, Enterprise Linux, CentOS, and Alma Linux, ALG if AAD is compiled directly into the kernel. The mod probe configuration file is silently ignored on these systems because the module load never goes through. Okay. Alright, so answer the question below. What command checks whether ALG if AAD is a loadable module or compiled into the kernel? So we ran... what was the command? Mod info ALG if AAD. Okay, we're very close to finished. Conclusion. Takeaways. The Linux page cache is shared infrastructure. One process writing to it affects every process sharing the same kernel, including containers that appear to be fully isolated by namespace and capability restrictions. Isolation at the namespace layer does not extend down to the page cache. Exploits with no race condition and no kernel offsets change the operational risk window. Public reimplementations of copyfail in C, Rust, Go, and ARM64 surfaced on GitHub within days of disclosure, along with the original Python release. Weapons this reliable are used quickly, not gradually. And okay, we've got another ad running on Twitch. So it is bird time. Let's put on... ooh, which birds this time? How about the greedy sparrow? Okay, so this sparrow is defending its food against the other sparrows. We'll be back in about 60 seconds, but enjoy the birds. You know, most of the time sparrows are perfectly happy sharing their food with other sparrows, but this guy is very unwilling to share. Anyways, let's put the greedy sparrow away, and we'll get back to what we were doing. Okay, so file integrity tools hash from disk, while this exploit writes to memory. For this class of vulnerability, detection requires syscall level monitoring, whether through audit D rules, watching socket AF ALG calls, eBPF based tools such as Falco tracking process behavior, or kernel level telemetry correlating the received message volume with the subsequent exec VE. File system monitoring on its own is not sufficient. The kernel update to these ones should be applied as soon as the distribution makes it available. The mod probe blacklist and it's an effective interim control on Ubuntu and Debian, but is not a substitute for patching. Okay, I can now exploit CVE 2026 this thing. Sure. And I think we're finished. Okay, so this was very educational. So if for any reason you come across a Linux machine and actually wait. So I guess the suitable detection for okay, let me load up the regular version of this room. Great name for an attack, by the way, the Greedy Sparrow. Yeah, I think so. Anyways, so a good detection for this would be to run this command over here. Huh. I don't get my... Okay, detection remediation. So we have to run... We could run this command to figure out if we have capability of running the exploit. So it's mod info alg if aad. Huh. Shouldn't this fail? Because we applied the patch? Invalid argument. Looking forward to the Dirty Frag box. Yeah, we're going to be doing the Dirty Frag box on Friday in a couple days. Did I spell this wrong? Mod probe ALGIF AEAD. Oh, okay. So yeah, it's not running because it should return an error if the module load is blocked. Okay. So this is not vulnerable anymore. Alright. So yeah. So because of that, the exploit script fails. Errors out, no worries. Alright, we're done. Okay. So we're going to be doing an extra activity today. And yeah. Let's go ahead and put a couple hours on that. Okay, so the last activity we're doing today, let me go ahead and pull it up on the overlay. So we're going to be doing HackerPol. So HackerPol is a French website, but I'm actually very interested in exploring this platform for some more. So let's see, this platform allows you to replay the challenges of the France Cybersecurity Challenge all year round to discover and trade in various areas of cybersecurity. So if you want the English version of the page, it's over here. And it's good that we don't necessarily have to do a lot of translation to do these challenges over here. The challenge difficulty on this website, it's higher than over at PicoCTF. On PicoCTF, you have some really easy level challenges. The standard of challenges for HackerPol is higher. Twitch just reported you restarted the stream. Oh, really? I mean, that's okay. That's okay. That's okay. We'll keep on going for a couple hours. And yeah, because I just want to do some CTF challenges. So if anybody has any questions about any cybersecurity stuff, feel free to ask while we solve these challenges over here. So let's see, challenges. We got crypto, forensics, hardware, miscellaneous pwn, reverse, and web. I mean, if we want to go back to our bread and butter, actually, maybe we can do some miscellaneous challenges. Okay, Docker and Netcat. I think we've done some of these before. So we'll do some introduction level challenges. This one's called Snake. I wonder what this is. Oh, it's probably some Python related thing. Okay, so this is the challenge. Sorry, everybody. Knowing the Python language can be extremely useful in CTF. Here you need to read the content of the file flag.txt. We need to read the file of the content flag.txt. Okay, so for hacker poll challenges, what we really want to do is we want to use Docker Compose to start up a Docker container that hosts the challenge. So let's see. I think we'll make a separate tab for Docker Compose. Or just Docker, I guess. And we'll make a separate directory for HackerPoll. And this challenge is called Snake. Okay, so let's go ahead and download this thing. Oh, we're using curl. Sure, why not? Okay, so we just downloaded a file called dockercompose.yaml, and this is what we're going to be using to configure our Docker container that we're going to be using to solve this challenge. So launch the challenge by executing in the same folder, Docker Compose up, and then we can access it with netcat. Netcat. Okay. Okay, so the Docker container should be running now. And I'll do another tab. We'll just call this Hacker Poll Challenges. And give this a fancy color. How about some blue? Okay, so the challenge wants us to access localhost on 4000. So there's a Docker container that's hosting the challenge on my machine on port 4000. If we run this, so this is taking in, hold on. So there is something running on localhost 4000. So if we run netcat on it, what kind of response is this? So if we send numbers, it looks like they're echoed back to us, but the name PW is not defined. Do you mean POW? POW? Echo response? POW. Built-in function. Are we using Python commands now? Print hello world. Okay. So yeah, this seems to be, this might be a Python shell. So if this is a Python shell, we probably want to run some OS commands. Run some OS commands. Oh, we got kicked out. So we connect back. Import pty. pty.spawn bin bash. What is this? Frozen OS. Let's see. Can we import pty? Okay. pty.spawn bin bash. Okay, that doesn't work. Maybe there's no bin bash. Right. So maybe bin sh might work. pty.spawn bin sh. Oh, we got kicked out. File not found. Okay, so go back, import pty.spawn bin sh. We're in. Okay, flag.txt is mine. We're done. Okay, that was interesting. I mean, I wonder if we could make like a callback. If we could open up another shell to give us a bit of a more stable connection. Because I'm pretty sure this is going to kick us out in like a few seconds. Alright, let's try submitting this flag. Challenge flag is correct. Nice play. Okay, we'll do a little write-up for this. Because we love doing write-ups over here. You could drop in a rev shell script and run that in the background. I guess we could. There's a lot of things we could do to stabilize ourselves, but I mean the objective is very quick to achieve after we get our shell access. Okay, so this is HackerPoll. Yeah, we made a directory for this. We did cryptography and hardware and web app. So this is the first one in the general category that we've done today, right? Miscellaneous. Okay, that's what they call it. So miscellaneous, this is snake. Okay, so we'll record a few different things. The URL where we can find the challenge, the concept we need to finish the challenge, and the exact method of solve. Okay, so the challenge is here. The concept we need to understand is running OS commands in a Python shell. So the Python shell is, I mean, it's very similar to what you would see inside of, if you just run Python by itself, then you've got your Python shell over here. So this is exactly the same thing that we saw in the challenge. So if we started running stuff that is not defined over here, it would give us these same kind of error messages. So what we did in the challenge was we did import pty, which imported the pseudo-terminal module. Then we used a function from this pseudo-terminal module called spawn, which runs a process. In this case, we ran bin sh, and this lets us escape the Python shell into a regular shell. There are a few different ways we could have taken this, but the easiest way to do it was to use some sort of shell escape. Okay, LiveStep says, this machine have Vi or Vim? You mean the Docker machine? I think the Docker machine did. So Vi or Vim, you can initiate using shell maybe. I mean, in this case, we're just working inside of like a Python shell. So, I mean, we could run any program we wanted to. Yeah, I mean, we used netcat to access the challenge here. But LiveStep, hello, nice to see you here. I hope you're having a good time. So running OS and commands in a Python shell, the method of solve. when we connect to the challenge, we see that we are within a interactive Python terminal. We can use a classic netcat shell upgrade technique to get an interactive OS terminal. So the commands we run are import pty, pty.spawn, bin sh, and the flag.txt file we need to read is in our current directory. Finis. Okay, let's move on to another challenge. So I guess what we need to do here is we need to tear down the other Docker container and then start a new challenge. So what's our next challenge? So we just did snake. Submit a solution. I don't think we need to. Okay, so the next one, let's do... I've lost my comment. I've lost my comment? Is this going to be like a Git thing? This one sounds interesting. It's called sushi, but this is the number of write-ups. I guess the more popular challenges have more write-ups. Wi-Fi. I mean, I'm not very good at like Wi-Fi hacking stuff. This one's called toilette. Does that mean toilet? What does this mean? I put a stirrer in my flag and stirred it. What? Reconstruct it. Reconstruct the flag. So we got two... Oh, we don't even have like a Docker container. We've got a Python script and an output.txt file. Alright, let's give it a try. I'll make a directory for this. Toilette. Is that how you spell it? Two L's. Okay, let's download those files. So there's toilette.py, and anybody who wants to do this challenge themselves, actually, I'm pretty sure you don't need to be logged in to download these files. Let me know. That's how I stir my flags. Everybody, let me know if you can download these files without being logged into the HackerPoll website. Okay, that's one, and this is the other. Okay, can download. Awesome. So we got toilette.py and we got output.txt. So I'm assuming that the script... Okay, so this is some sort of... We have to apply some sort of transformation to this. Let's take a look at the Python script. Flag equals open flag.txt in read mode. Assert length of flag equals 64. So 64 characters. Is this a sanity check challenge? Okay, let's just try running the script. Open flag.txt, no such file or directory flag.txt. Oh, I see. So the output, we need to reverse this. So output.txt is the flag after it's been transformed. So what if we copy output.txt and call it flag.txt, and then we run the script. Length of flag 64. So that should be okay. So what we need to do in this case is we need to slowly pick apart the toilet.py script to understand what it's doing. I put a stir in my flag and stirred it, reconstruct it. Okay. Alright, let's go back in. So let's make a copy of this. Just so that we have a clean version after we start modifying this. Okay, let's make this nice and big so that we can all look at this together. So this is how the program reads the flag. Okay, so flag equals open flag.txt in read mode, and this. So assert is a keyword I don't really see very often inside of Python. Let's just double check what it is. Python assert. I'm assuming that assert is like a check that something is of a certain length in this case. Okay, the Python assert keyword is a debugging tool used to verify if a specific condition in your code is true. If the condition evaluates to false, Python raises an assertion error, typically halting the program and signaling a bug. Okay. Assert tests for conditions at runtime and bails if it is not true normally. Okay, so assert condition optional error message. Okay. So this one is going to ensure that the length of the flag is 64 characters long. And if it is, then it's going to flag file contents is exactly 64 characters in length. Okay, and this looks like so x equals empty string.join. Empty string.join -8 -8. This splits up the flag into multiple chunks. And joins them together. So how can we put a comment in the middle of this? So flag, I'm assuming that flag is a string. So flag is a string, they -8. -8 means the 8th character from the end. So let's assume that we've got the flag looks like The flag is a string that looks like this. Flag equals, it's going to be exactly 64 characters long. So this is 10 characters, 20 characters, 30 characters, 40 characters, 50 characters, 60 characters, 64 characters. So this is 64 characters in a string, and so it joins the character at -8. So this is -1, -2, -3, -4, -5, -6, -7, -8. So it takes the character at -8, and then it skips by -8. This is interesting. So let's try recreating this. So let's put this over here. We'll make another window where we're running some Python script over here. Okay, let's get into that directory. Okay, and so this will be a little script. We're going to call it test.py. So our flag is going to be this. And then we're going to try printing this out. So flag print. Actually, maybe we should do this as an interactive Python console. So just write. So this is the flag string right here. So print flag -8 -8. So what I'm assuming here is that we start at -8 -8. Are we going in reverse order? So this prints out 79135,791. So this is 8 characters. So it starts from here. And if you put -1 at this position over here in the string slicing, it prints out in reverse. But what does -8 mean in this case? We see 79135,791. So does it skip every 8th character? Does it skip 2 every 8th character? 1, 2, 3, 4, 5, 6. Ah, okay. So it starts at the -8 position, and then it skips by 8 characters into the string every time. So 1, 2, 3, 4, 5, 6, 7, 8. So 791. Interesting. Okay, so I think I understand part of what's going on. So it rearranges the flag, it grabs little bits and bytes, and then it joins them all together. But that doesn't explain why the output is not 64 bytes. So I guess this is where this comes in. So print X starting at 1 and then doing every second character. And then we add the same thing starting at 0 and then printing out every second character. So this is, I mean, it's a big jumble happening here, huh? So I guess what we would do is we would run all this in reverse. Because I'm pretty sure that means so this starts at the second character and it prints out every second character. This starts at the first character and it prints out every second character. Okay, let's... So output.txt, this has the entire flag. But what's the word count on this? This is 65, so there's one extra character. There's one extra character because of the line feed. Hold on. Is that it? Okay, so yeah, okay, there is a 0A character over here. Yeah, that makes sense. Okay, so I mean we can probably like delete this extra character, right? Nano. Huh. But does this character also, does this flag.txt copy also have the thing? Yeah, it also has it. So how do we delete this then? XXD, no. TR delete. Nano adds one automatically. Nano adds one automatically. In the default configuration. I mean, we could delete this with can we do with sed maybe? Sed delete. Okay, delete the new line character using sed. You must handle the fact that sed is typically line oriented and strips new lines from its pattern before processing. Oh, okay. Ah, okay, okay. Can we write this? It still has the line, the new line character here. If we wanted to really strip it out, maybe we could tr delete. Cat flag.txt, strip it out with trd, and then write it out to flag2.txt. Okay, so this one doesn't have the new line character anymore. So this one's exactly 64 bytes. So what happens if we feed this to the... If we feed this to the toilet Python script... Huh. So this still doesn't register as 64 bytes. Although it says 64 bytes here, length of flag is not 64. Okay, let's Python command So if we do flag new flag equals open flag2.txt in read mode, unterminated string literal. Oh, okay. Gotta close this off. And then print length of new flag. $64. Yeah, so I'm not too sure why this doesn't work, because the length of the flag file that we give to the script here is 64. I wonder why it's assertion error. Why is it erroring out here? Assert length of flag equals 64. Open flag.txt in read mode. Oh, okay. It's because it's hard. Yeah, this is, I wasn't using the right file. That's a typo. One of these. Anyways, we'll run the file now. Okay, so this is even more jumbled now. So we need to reverse engineer the stuff that's happening in the script. Okay, so the first thing we need to do to... Actually, you know what we can do? So we got our new flag over here. So the new flag is the... whatever it is. So print new flag. This is our string. So let's try to do the modifications inside of here. So first we need to reverse this operation. So to reverse this operation, it's going to be... Let's make a couple of new strings. Okay, it looks like we got ads running on Twitch right now. When ads run on Twitch, we'll also run them on YouTube. And let's put on some new birds. How about... Oh, you know what? This one's a classic. We've got some birds. One bird bullies the other bird. And you can watch the fun. We'll be back in about 30 seconds. I just need to have a little water break. I have no idea what's actually going on here. I used to think there was one bird bullying the other bird, but I think the relationship between these two birds is that the bird on the left-hand side is the baby bird, and the bird on the right-hand side is the mama bird. But anyways, that was some interesting bird interaction. Alright, so if we want to reverse this, the first thing we need to do is we need to split this up into two different strings. It's two strings concatenated to each other. One contains every second character. One contains every second character but begins with the second character. And the other one is every second character, but it starts with the first character. So the first thing that's here is the second character set, and the other one is the first character set. So second character set equals new flag so this is going to be split exactly in half. So it's going to be new flag starting with 0 up until 32, 33. So this isn't going to include the 33rd character. Okay, so this is second character set. And there's going to be first character set. Which is new flag from 33 to the end minus 1. Okay. So let's try printing those out. Right. So second character set is this. First character set is this. That doesn't seem equal in length. Hold on. This does not seem equal in length. This is 33 characters long. Hold on. Okay, so let's redefine this. So the new flag is going to be 0 to 32. Okay, it's supposed to be 0 to 32 because this is actually 33 characters. Because 0 counts as a position. So this should actually, yeah, I think this should be it. So 0 to 32 is 32 characters. So that's second character set. First character set is going to be the 32nd character up until -1. So that's supposed to be first character set. And let's print those out. Huh, they're still not the same length. So the first character set is (31 characters). Wait. What character are we missing then? Because if we just print the new flag, this should be 64 characters in length. Yeah, this is 64 characters in length. What are we missing? So second character set is (0 to 33. I must be getting something wrong with the counting starting from 0. So this is 33 characters. Actually, let's just try printing it out. Print. Okay. Let me check the length of this. This is 31 characters. This is 32 characters. So this is 31, this is 32. And then, so let's define this. Doodlers, hey, what is up? Why are we talking about Chinese food? Okay, so we'll call this the second character set. Doodler says, I'm in China right now. Are you the president of the United States? Maybe? Yeah, I guess you could be. Okay, so let's try printing out this flag from 32 until -1. Actually, maybe we should be using -0 instead. So -0 doesn't. Yeah, this doesn't work. But this doesn't include the last character. Yeah, how can we slice this but include the last character? So is it just leave it blank? Okay, we just leave this blank. Good old string slicing. Okay, listen, doodlers. We're here doing cybersecurity stuff. If you're a cybersecurity student, let us know. If you're not, then maybe not. Maybe don't talk about politics and stuff. Okay, so we've got our two halves. All right. If you really want to chat, come back in a day, okay? All right. So we've got our two halves, right? So this one is first character set. Okay, so after that, if we print these out, these should be equal length. I was thinking the same, but more like 10 minutes to start with. Well, I mean, you know, he's probably not super interested in what we're actually talking about here. If he wants to, we can come back on Friday. Okay, so the first character set is here. The second character set is here. They're equal length. This is good. Next, we need to start dissecting this some more. So in each one of these cases, we're skipping back by 8 characters to form the initial chunks. So each one of these. So this thing is going to be 64 characters in length overall, and each one of these chunks is going to be 64 divided by 8. So it's 8 characters each. So it's 8 characters, 8 characters, 8 characters, 8 characters, 8 characters, like this. So this is split in half. These are 32. So the next thing we need to do is we need to put this back into its original order. So we'll call this the joined string. So joined string is going to be first character set So dot, what was it? Empty string dot join. Actually, no. Maybe it is. Join. So it's going to be the first character set. And the Beldam. Hello, nice to see you here. What is up? Join the dark side, we have cookies. Wait, where is that from? That's a quote, but I'm not too sure where it's from. So we recreate this. First character set, second character set. It's every second character. I only know a bit of Python. Yeah, I mean, some of our current challenge right here is trying to figure out what all the Python commands are doing. It's a meme from fans. Oh, okay. It's not from any specific show. Gotcha. So what I think we want to do is something like this. Okay, so Python alternate Python create new string from alternating characters from two different strings. Because that's what was done. To create a new string from alternating characters of two different strings in Python, the most common approach depends on whether the strings are the same length or if one is longer than the others. So we can use zip if they're the same length. If both strings are of equal length, you can use the built-in zip function to pair the characters and empty string.join to combine. So string 1 equals this, string 2 equals this, pairs A with D, B with E, so result equals dot join AB for AB in zip S1, S2. So the output would be ADBECF. Yeah, like this. I think this is what we're looking for. So something like this. So let's edit this before we. What do we call this? Recombined? We'll just call this the recombined string. So this is going to be A plus B for AB in zip S1, S2. So there's two strings we're dealing with is first character set, second character set. Okay, so we'll try this. Okay, and then we'll try printing it out. Okay. I mean, I'm not I'm not exactly sure if this is what we want, but I guess we can continue from here. You know, it's going to be really fun trying to reconstruct this when we do our write-up, if we manage to find the right string at all. But anyways. So I guess what we need to do is we need to reverse this this function right here. Okay, so to get the reverse of this function, this join function here, so we need to start at, so this is -8, then -7, then -6. So to get the reverse of this, and this is 8 characters long. Each one of these chunks is 8 characters long, so 8, 16, 32, 40, 48, 56, 64. Actually, wait, they're not 8 characters long. Does that not reverse each 8 blocks of characters? I mean, you'd assume so, but there's too many here. 8, 16, 24, 32, 40, 48. Oh, no, it is the correct length. 48, 56, 64. Okay. What is the programming language? So we're using Python. Python, we're trying to reverse a Python script that jumbles up a bunch of characters. So these are, we probably want to go in reverse, right? So the reverse of this would be x equals, so basically the same thing, but reversed. Sorry, I'm a noob. No worries, no worries. We're all struggling here. I wish I was a better Python programmer than I am. Okay, this would be flag. Flag join. So we'd go in reverse order. So we'd be doing -1, -8, -2, -8, like this, right? This requires some major Python foo, yeah. So let's try this. So flag 2 -8. And then just keep on, just do it in reverse order like this. and just keep on going. I wonder why there's a comma at the end. Seems kind of weird. Okay, so kind of like this, but let's just put it all together into a single line. Okay, so we'll save this out, and then we'll see if we can put it in our console here. Okay, so let's rename recombine string into flag. Flag equals recombined string. And then we set this as X. And then we print the flag. And we print X. Okay, it still doesn't look like is this a hacking simulator? No, it's not a hacking simulator. It's just a programming challenge. So the programming challenge, we got it from over here on this French cybersecurity education platform. So there's still something wrong here. So something I guess what we need to do is we need to get each one of these chunks. We need to get each one of these chunks and then populate a new string. So if this is our recombined flag, or our recombined string over here, each one of these chunks is 8 characters in length. So that's 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8-character chunk. This is an 8-character, well, this is an 8-character chunk. And then up until here, I'm guessing, is an 8-character chunk. So all the way back over to here. So what we need to do is we need to split these 8-character chunks into separate strings. So this is starting from the back and then slowly going forward. So what we need to do is we need to split these chunks into 8 characters each. So we're just going to call these chunk 1 to chunk 8. So chunk 1 is going to be flag. Do we start from the... Yeah, okay. So chunk 1 is flag 0 to 7. Actually 0 to 8. Let's just print that out first. Print So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 characters. So we'll call this chunk 1. And then we'll do chunk 2, which is flag starting at the 8th character, or the 8th object, so which is object 9, until 15. Actually, let's print it out first. So this is not enough characters. This should go to 16. So this is chunk 2. The counting from 0 always gets me. Okay, so this is chunk 2. And then we'll print off 16 to 24. Okay, that looks like the right length. So we'll call this chunk 3. We got chunk 4, which is 24 to 32. And we got chunk 5. Before I continue, let's put on some music, because if it's just me struggling with Python without music, then that's no fun. But if we're struggling but we have music, then it's much better. Okay, so chunk 5 is 32 to 40. Chunk 6 is 40 to 48. Chunk 7 is 48 to 56. And the last chunk is just 56 to the end. Okay, let's just print out chunk 8 for fun. Oh. We need to put a colon there. Yeah. Okay, so this should be 8 characters. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is reversed. What we should be doing is we should be string reversing all of these. So we'll go from trunk 1 equals chunk 1 minus 1. So this will string reverse this particular chunk, right? Actually, let's just call this rev chunk just in case we need to recreate this. So rev chunk 1 equals chunk 1 in reverse order. And the same with all these other ones, but we replace the numbers. This is going to be such a huge pain in the butt to reverse, to do the write-up for after we're finished. But you know what? I might take a look at some write-ups if I'm able to get the correct flag. Okay, so we'll print this out. Rev chunk 8. And this might be the correct thing. So the last thing we need to do is we need to reconstruct the parts of the flag by using the kind of zip operation that we did earlier over here. So join AB, well, I mean in this case it's going to be AB, but the zipped up thing is going to be rev chunk 1 to 8, which not exactly super fun. So this is 8 letters, so it's going to be result equals join. Actually, we should probably give this another name. Final flag, maybe. It's going to be A plus B plus C plus D plus E plus F. How many of this? This is 1, 2, 3, 4, 5, 6. G plus H. So this should be 8. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we need to for A, B, C, D, E, F, G, H in zip rev chunk. So we need to repeat this 8 times. Just a second. Is this 8? 1, 2, 3, 4, 5, 6, 7, 8. Okay. 7, 6, 5, 4, 3, 2, 1. Okay, let's plug this in. Wow, that looks like a proper flag. The flag format is correct in everything. So FCSC is the correct flag format. We got our curly braces over here, and let's submit this flag. I wonder how long I spent on that. Was that like 30 minutes? Was it closer to 60? I'm kind of embarrassed at how long that took. Alright, let's, but the important thing is that we got it done. Okay, so submit the flag. Challenge flag is correct, nice play. Okay, so... okay. Everybody, we can, not using AI to auto-solve and not learn, how dare you. Not using auto-solve and not learn, how dare you. Well, I mean, we did use some AI to help us come up with this stuff over here, but mostly not using AI. But dumbass hackers, hello, nice to see you here. I hope you're having a good time. Anyways, we've got a special emote for people who are subscribed to the channel called the Shy31 flag, and this is what we spam when we get our flag. Especially huh. Why did that not go through? Okay, it did go through. Anyways, that took a long time. Alright, let's try to do a write-up for this, because this was not very fun, and if I need to repeat this, I want to know how to do it with a minimum amount of pain. So it's called Toilette. Okay. We need the URL for the challenge. We need the concept to solve the challenge. And we need the method of solving the challenge. I suppose the best thing to do would be to figure out how to do this all-in-one Python script, right? Okay, so the URL for the challenge is here if you want to try it out yourself. The concept here is we need to reverse a lot of string slicing operations in Python. Okay, so the method to solve. We are given... Actually, you know what? I might do the write-up for this off stream, because I really want to move on to the next challenge. I don't want to spend all day on on this thing. Okay, so let's do another miscellaneous challenge. Actually, maybe we could do like a web challenge, because we like web challenges over here. Okay, we got meme generator, NES forever. NES forever, huh? That sounds like some... That sounds like some fun. Okay, let's give this a try. Okay, so if you're following... If you're on HackerFrogs, then what you need to do is you need to deploy your own Docker container that contains the challenge. Let's see. Launch the challenge by executing in the same folder, Docker compose up. So this one's called like NES forever. Let's make a directory for this. I'm going to keep this in the background. Okay, so this challenge is called NES Forever, and we'll make a directory for us. Okay, so the Docker compose link is over here. And then we will start up the container. I'm pretty sure... Okay, so this should be running on localhost port 8000. So let's check it out. Localhost 8000. Okay. Oh no, it's in French! Okay, NES Forever, apropos, le site de référence pour les fans de jeux 8 bits. Oh, okay. This site is a reference for the fans of the game of 8-bit games. At least I think that's what it says. Let's do a translate on this. Let's see. Translate section to English. This reference site for fans of 8-bit games. Okay, close enough. Okay, and I thought you were Canadian, so half French. Do you Okay, let's talk about misconceptions. Okay, there is one province in Canada where French is the primary language. Every other province has a mandatory French language education, but only until 8th grade. So that is age 13, I think. The quality of mandatory French education is very bad. Okay, that was a joke, not a misconception. No worries, no worries. But yeah. The interesting thing about French is that French language proficiency is required for political jobs in Canada, as well as many government jobs. So if you do not parlez-vous français, then you can't achieve a lot of you can't have a political career in Canada. So that's a fun little tidbit about my home country. So promo le compte premium est seulement à €1 cette semaine. Let's translate this thing. Premium account is only $1 this week. Okay, that's great. And we've got our social media. So this all leads to the same stuff. Top games: The Legend of Zelda, Super Mario Bros, Mega Man. Okay, so this is... Okay, these are not links. They don't go anywhere. Top players: Medeo. So something about helping him, helping this person. All right, let's translate this. If you were offended by my horrible French, I'm sorry. Okay, I cannot finish Zelda. Someone would have a code to help me. Okay. So what's this? Person. Explore the site. Something. Have a good trip. Explore une profondeur ce site. Tu devrais y trouver ton bonheur. A good hour? What is this? Explore this site in depth. You should find your happiness there. Find your happiness there. Huh. Okay, so I guess NES forever. Alright, so the first thing we want to do on this site is take a look at... So we got some CSS. The CSS is probably what's creating the 8-bit graphics. Is that it? Wow, this was very underwhelming. I thought there would be something a little bit more tricky about this. Let's try submitting this flag. Okay, flag this. Alright, well, that just means that we can move on to the next challenge. I mean, I guess I can do the write-up for this like super quick. I actually forgot that I did 3 challenges in this the web category last time. Okay, so URL. Let's just grab the URL for the challenge. The concept, this is just HTTP source code inspection. Okay, so the method is solve for this one. Just look at the HTTP source of the landing page. Finis. Okay, let's let's move on to the next challenge then. Okay, so do we want to do forensics, crypto? Let's do a forensics challenge since we're doing the forensics category in oh, this is memory forensics, Windows. Okay, that doesn't sound like a lot of fun. We have some Docker forensics as well. So I have some disk forensics. Maybe a disk forensics challenge might be fun. So this one's called Not So Fat. If you want to try this out yourself, here's the link. You should be able to access this. Okay, so we're just gonna... So this challenge is called Not So Fat. And let's download the disk image file. It's a big file. It's, what was it, 100 and some odd megabytes? No, 16 megabytes. Still kind of big. It's not going super quick. I guess they don't have very much resources allocated to this. Okay, so notsofat.dd, this is a disk image file. So this is DOS MBR boot sector. DOS MBR boot sector, huh? So previously, when I was doing PicoCTF, what we'd do is we would use disk sleuth. No, not disk sleuth. It was called SleuthKit. So SleuthKit has a bunch of different tools we can use for disk image forensics, including MMLS. Okay, so MMLS usually lists out different partitions if an image has multiple partitions. But in this case, it looks like there are not multiple partitions. I kind of forget what my workflow is for SleuthKit. So it's MMLS and then I think it was FLS. Okay. Huh. Interesting. So there's a flag.zip file. I think these are deleted files. So there's flag.zip. We got some orphan files here as well. So there's actually not very much here. Let me look back at my notes for some of the other disk image forensics challenges. Because I've done some on PicoCTF. Let's look at some of the later ones. Maybe from 2024. Where are my forensics ones? Here they are. Oh, that's Wireshark. Okay, I'm gonna look on my notes on my local system. Okay, so it looks like what we can do is we can do FLS to see the contents of the disk image, -P-R on not so fat. Christian Rink, I'm not too sure what you're trying to talk about here. For the file, so the file is 5.2. This one. Nothing there. How about this one for flag.zip? Ah, okay. So this is all right, so this is a zip file. It's a zip file, which means we can ICAP this out, and then we can restore it back into its original form, called flag.zip. Okay, this is a zip archive, and I guess what we need to do is we need to unzip it. Password. We don't have the password. Okay. So we need to get the password from somewhere. So there was another file on here as well, right? So there's this other strange file. We don't actually know what this is. Let's try reading it. So this is the inode is 4. We've also got these two entries over here called MBR, FAT1, and FAT2, and the orphan files. This is an empty file. So what else could we use to identify this thing? Let me see if I can get some of my other notes. So we see here that there's something called orphan files. Usually when things are deleted, they're going to be put into something called orphan files, right? So can we read it? There are these other things as well. I mean, we can just try to read everything. This is not a bootable disk. Please insert a bootable floppy and press any key to something something. So this was the what? The MBR? Orphan files are chunks that are recovered from deleted files. Oh, okay. So let's redirect this into, well, we'll call this MBR. This is a .boot sector something something mkfs.fat. great. We'll do the same thing for the other files as well. So this was 04 is FAT1. And then 05 is FAT2. And the last one is orphan files. So we'll call this orphan. Okay, now we've got a few different files. And how many of them these are? So orphan is empty. So this is empty. FAT1, FAT2. This is ISO text. This is ISO text with no line terminators. And this one is also So FAT1, FAT2. I suppose what we would want to do is we want to take a look at the hexadecimal for this. This is mostly empty. Is this entirely empty? Binary data there. Yeah. This doesn't help. So FAT1 is just a bunch of junk data. So FAT2 is also just a bunch of junk data. Okay, so I mean flag.zip, we don't have a password for this, but we can probably, we might be able to just, what is the word? Crack the hash. So let's see, we do John to zip to John. Zip to John on flag.zip and output it to zip.hash. Brute force it? I mean, we can try. Okay, so we've got our, yeah, so we can just run John with the word list on zip.hash. Okay, the password is password? Everybody, listen, the password is password. Okay. ECSC, huh. Usually this is not the flag format, but I guess I'll submit it. See if it works. Just a second, everybody. Correct format. Okay, okay, that was the flag. All right, we're gonna take a break because we got ads on Twitch right now. But let's go ahead and put on some fun birds. How about my favorite one? Everybody, this is my favorite video of the fledgling Stellar Jays. Enjoy the birds. We'll be back in about 45 seconds. Okay, so those are the birds. We'll put them away. So we managed to get the flag for this challenge. I mean, I guess that means we need to give ourselves our flaggy mode over here, like this. Okay, so we solved the challenge. It was a two-step process. The first thing we needed to do was we needed to extract the flag.zip file from the disk image, and the second step was we needed to crack the password for the flag.zip file to get access to the contents of the archive. So let's do our little write-up. So this one's for HackerPoll. This was for forensics. I don't have one for forensics yet. Okay, create a new file. And this was called Not So Fat. Oops. So we need the URL, the concept we need to do the challenge, and the method of solving the challenge. Okay. So here's the link. The concept here is recovery of files from a disk image, as well as cracking zip file hashes. Okay, the method to solve. What do we got? Bezrikia! Hello, nice to see you here. What is up? We're just doing some CTF challenges to round out our evening of cybersecurity and infosec live streaming. Hope you're having a good time. Okay, the method to solve here is use the MMLS tool from SleuthKit to figure out if there are multiple partitions on this disk image. There are not. So we should list out the contents of the disk image with the FLS command. FLS tool, FLS tool. Okay. So I guess we should also include the commands that are being used. So MMLS on, what was it, not so fat .dd. So the next command is the FLS command. Okay, let's see. KKMZ says, what was your path to cybersecurity? Are you a prodigy, or did you start hacking games? I'm not a prodigy. I got into cybersecurity as a career change at the beginning of my 40s, and I'm in my mid-40s now. So if I was a prodigy, I would have started my cybersecurity career when I was 12 years old or something. What was my path to cybersecurity? I guess I can talk about it very briefly. Let's see, got interested in cybersecurity / pen testing roles in 2020. Studied offensive security for 18 months. Got involved in the local community. Making lots of social contacts. Got my first job as a web app pen tester after a year and a half. Got burnt out slash, let's see, got burnt out in the role and wanted to pivot after half a year. Currently doing cybersecurity education online. Still active in the local cybersecurity community. Are you self-taught or did you have a background in IT? I did not have a background in IT, so most of studying offensive security in 18 months includes basic computer networking stuff. Still active in the local cybersecurity community. Do a lot of volunteer work slash workshop presentation. Currently. Okay. Bezrikia says, I enjoy watching your videos. I especially like the music you use in your methodology. Please keep doing what you're doing. Thank you. Thank you very much for your kind words. Bezrika says, let's see, I've been following you for a long time. I'm a Turkish student living in Macedonia, and I'm currently a third year computer engineering student. I'm doing an internship in pen testing at my facility. Oh, at my faculty. Okay. SysOS says, I don't know anybody who's a prodigy in cybersecurity. I mean, I don't know. If I was to do this again, I probably wouldn't take the path that I took to get into cybersecurity. But I was in a big rush, and I really wanted to get a job as soon as I could. But to people who are not in such a big rush, I'd recommend pivoting into cybersecurity from another role first. So doing either web app development to get into web app security, or app development to get into a role like, I don't know, DevSecOps or whatever. Okay, your career path is actually very similar to mine. Oh, really? Okay. Okay, so should list out the contents of the disk with the FLS tool. So that's going to be FLS-R-P, I think. This is not the right one. Yeah, -P-R. Oops. Okay. So KKMS says, I'm in my early 20s, self-teaching networking. What was the practical way that you learned? I'm messing with Kali and reading books. I mean, if you want to learn about networking, I've got a very good, I've got a website that I recommend to people over here. I've also have like a large list of education links over at the HackerFrogs GitHub. Okay, Bezrikia says, in my opinion, there are a lot of they are great for fast solutions and quick analysis, but for products that are meant to be used continuously and reliably, I feel like the industry is moving in a risky direction. Risky direction. So are you talking about, AI-powered cybersecurity products? I mean, who knows what exactly is going to happen to the entire IT sector when this whole like IT hype cycle finishes. It's very hard to say. Like AI-powered cybersecurity solutions, it's hard. It's also hard to say whether or not they're going to be cost-effective, I guess. I mean, we know that AI agents are able to find vulnerabilities, but how long they take to do that, and whether or not they get stuck in like recursive loops that they don't get out of, that's a hard thing to say. I'd say that the tools are best operated not autonomously, and that there should be a human operator in place to make sure that the AI is not going off the rails. Okay, so we use the FLS tool to get the file system list, the list of the the files on there. So there is a, let's see, flag.zip file. On the disk image, which we can extract. Using the icat command. Actually, I guess we can call all these tools. So the icat tool, let's get that. This one over here. So icat, we need to specify the inode, and then we need to redirect it into a file name. In this case, it's flag.zip. Okay, so the zip file is password protected. We can try to crack it. Crack the password with John the Ripper. Okay, so there's a couple of commands we need to do to crack the password with John the Ripper. The first thing we need to do is we need to run the utility program. So it's zip to John on flag.zip, redirect into zip.hash. And then we run John the Ripper. What's that command? Yeah, so John with our word list on zip.hash. Just like this. Done. Okay. All right, maybe we can do one more forensics challenge. Let's take a look. So challenges, forensics. This is Windows memory forensics. We also have Linux forensics. What is this? What is the name of this challenge? Okay, KKMZ says, how long after learning the basics would you recommend TryHackMe, Hack the Box, and CTF? I know they're very good for practice. I mean, the first thing you want to do is you want to figure out which role you want to do in cybersecurity, because depending on which role you want to do, that really changes the direction of your training. So the first couple of steps in getting into cyber, identify which role you want to aim for. Gather a list of resources. That will provide relevant training/education for that role. So the reason you want to do this is the training for web app pen testers is not going to be the same as the training for malware analysts or GRC compliance officers, or what's another incident response. So these are, there's not going to be very much overlap between the training of these different roles. SOC analyst, that's right. Okay, as far as TryHackMe, Hack the Box, and CTFs are concerned, I mean, try everything. So I'd say that Hack the Box Academy has lots of good stuff. Of course, I'd prefer to recommend free resources. So Hack the Box Academy, TryHackMe is also very good. Scilab Academy. Formerly PicoCTF is also very good. So use everything at your disposal, basically. There's no such thing as having too many training resources, unless you're trying to split your time between all of them equally. Identify the education platforms that fit closest to the kind of role that you want to train for, and focus on those. Okay, I think we might call it pretty soon, since we did just finish a challenge. Let's take a look at who is streaming right now. Okay, we got BlazeBits. BlazeBits is on. He is he's a current security. I think he does pen testing, but he's always talking about cybersecurity, and he's usually talking about cybersecurity news. Let's take a look at what BlazeBits is up to. So, Hack the Planet cybersecurity news and Q&A. Yeah, so I mean, if you want to ask about getting into cybersecurity advice, BlazeBits might be a good resource. But let's start our raid. But let's see. We'll start the raid, and then we'll talk about what we're going to be doing on Friday. Raid BlazeBits. Okay, so what we're going to be doing on Friday, today's Wednesday, of course. So the next stream is going to be on Friday. We're going to be doing web demos for PicoCTF. We're going to be doing more digital forensics labs, digital forensics lessons with HackerFrogs, and we're going to be talking about another very recent Linux privilege escalation vulnerability called Dirty Frag. So we're going to be covering that over at TryHackMe. And Intersect Forever says, a good stream, see you Friday. Hey, thank you very much. And when you go to BlazeBits' channel over there, if you could give this message, I would really appreciate it. It's going to be OSFrog, Hip Hop Hack, OSFrog, just like what SysOS Master has. Alright, everybody, we'll be back on Friday. Hope to see you then. HackerFrogs out in 5, 4, 3, 2, 1. See you Friday, everybody.